level. Like, everybody here has a home router. Do you know what firmware is running on there? Do you have antivirus on your home router? Do you do patching on there? I personally don't, I'm sorry. I'm sure lots of other people don't either, which is interesting. Like, denial of service bots are really not that cool to look at. They're very simple, but also they're very effective, and nowadays apparently they're involved in armed conflicts, which is strange times we live in. So, almost at the end of the slide deck, are we solving the problem? Like any problem, really. I tend to say yes. There is issues we fixed, like exploiting a buffer overflow on a fully patched Windows platforms these days is not that easy anymore. But making it harder, we push that bar up to a level where people either don't want or can't go there anymore, and that's a step forward. And I said this cautiously, like, you've seen there is enough buffer overflow exploits still out there, so maybe that's not a good example. But like, it's getting harder and harder for attackers in the overall view of the system. But so like, I talked about a lot of those cool research fields of like, hey, can we take down an airplane in mid-flight from a passenger seat? That is nothing compared to like the problem that we have with ransomware. Like, if you ever done incident response in the hospital while every system was down because ransomware was like creeping through the wires, and doctors didn't know what diseases their different patients had, like what ailments they needed, the pharmacy didn't know what medications to order, and they told us like, we're running out of medications to feed to our patients like in 10 hours. If the system is not back up, like, we don't know what to do. Suddenly your job becomes like very, very stressful. And ransomware is an interesting example because like, we don't have a fix, right? We have antivirus, we try to stay on top of that field, like people developing ransomware, we try to stay on top of those campaigns. But like, other than that, there isn't really a switch you flip on your computer to say no more ransomware. Like, there's no good protection that's out there. If somebody would like to like research that field and come up with something, that'd be great. That'd be helpful. Similar thing with DDoS bots and Bitcoin miners. There's a lot of places where malicious miners are running, like not the thing that you started on your cloud instance, but like some attacker's Bitcoin miner. That might be one of the more prevalent pieces of malware these days, and there's no good mitigation either. They're really simple. Like they are not runtime packed. They don't do obfuscation. Some of them come with big old banners like strings that say, "Hello, I am a something something Bitcoin miner," and you would think that that's detected and mitigated. It's not. Yeah, and there's some other rather simple ways that there are security problems these days, like phishing. It's an evergreen. There's still companies trying to detect phishing emails, and they're still failing. I get phishing every day. Like, I don't know what advances we had in that field. It's not moving very far. So like, you pick a field and you'll find problems that are unsolved. And I think that's why most, if not all of us, are still employed. Security is still a problem, for the better or worse. And yeah, let's keep going. The conclusion I have for this talk is like, everything's difficult. That doesn't help anybody, right? Research is hard. Research should be done. Research is at the basis of all of these advances that we've seen in the field. The ransomware problem would be much worse if we didn't have anybody out there analyzing those binaries and coming up for detections. I kid you not. Phishing could be so much worse if we didn't have email filters. Like, things happened in the past couple decades. The field has gotten better. And yeah, it's all thanks to security research. But so what I tried to say here is every step of the way is difficult. The research is the most fun, the most exciting element. And like, I thoroughly agree. Like, I like to do that too. I like to get lost in the rabbit hole. But like, from that rabbit hole, there's still a long list of things that need to happen for that research to actually help anybody. Not every research needs to help someone. Some research should. Like, the needle should move forward in terms of security slowly but steadily. Things need to happen. Is it your job to do that? I don't want to put it on you or me or anybody else. But think about it the next time you find a bug. Not to say, like, think about those poor security engineers on a Friday night that get bombed with a report and then need to go patch systems. But like, yeah, impact is nice, isn't it? So finally, not to say without research, we're not going nowhere. If you guys stop finding bugs and stop writing proof of concepts, what are we going to patch? Patch management is a nightmare. But like without the vulnerabilities, that field wouldn't have anything to do either. It couldn't have an impact if they wanted to. If we stopped finding and analyzing malware, we wouldn't have any more signatures. What would we do there? Like, couldn't protect anybody either. So yeah, and a quote that one of our senior scientists said at some point, which I liked a lot, like, if everything we try works out, we're not trying hard enough. So like, not every piece of research can have a world-changing impact, and it doesn't have to. That was it. Thanks for your attention. Is there questions? Is there time for questions? Does anybody have questions?
good and stuff? All right, cool. So this is building a Windows VMI, which I'll talk about, but that's virtual machine introspection system with basically no knowledge about Windows. So yeah, I'm Rowan Hart. I used to be a CTF player at Purdue University when I was in college. I don't do that anymore because I'm busy now. And I also used to work on system software fuzzing. I was here last year to talk about that. I used to work at Intel until they decided they were going to pay a bunch of people to leave, and I said, okay. I'm also a hobby hacker, side project collector. Almost none of that stuff is done, but you know, we'll get there eventually. And most notably for this talk, I'm not a Windows person. Can you hear back there? All right. Can we crank it a little bit, or? All right, maybe I'll just hold it. Is this better? Okay.
Or we can come closer.
This should be okay. Ah, there we go. All right. Maybe I'll start again. I used to play CTF. I'm busy now. I used to work at Intel on system software fuzzing until they paid me to leave the company. So I'm not here representing any employers, which is kind of fun. I do hobby hacking. I do side projects, all that good stuff. And I'm not a Windows person. So until like last week, when I started working on this stuff, I had like touched no Windows internals or anything like that. So it was entirely new to me, which was kind of fun. And you can find me on most websites at Nova Facing if you're interested in that. All right, so I was working on a fuzzer. That's what I was here last year to talk about. It fuzzes UEFI, it fuzzes Windows kernel, it fuzzes Linux kernel. And it's going great. I was using it. I was finding some bugs and stuff. And I gave it to some engineers, and they were able to find some bugs and stuff too, especially like on the UEFI and Linux kernel side, which was great. It's, you know, built on a simulator, so decently fast. We're talking like 5 executions per second. That's actually quite good, unfortunately. And everybody was pretty happy with it, except when it came time for me to use it on a bunch of projects. When I said, "Ooh, I kind of just want to work on the fuzzer. I don't really want to actually go try and find any bugs. That's not really my thing right now." And so I, you know, tried to continue working on the fuzzer. So what I did was I just handed the tools to all of the developers and said, "You guys have your you know, Windows kernel applications and drivers and stuff. Go ahead and find your own bugs." And they said, "We don't really like that," because that's how I was giving everybody information on coverage for their Windows kernel drivers. Now, like technically, you can get everything you need out of that. It's got program counters, and it tells you what the program counter is at every branch. And if you look really hard, you can say, all right, this one comes before this one, so we must have this control flow. But nobody really likes doing that, especially not when you're fuzzing with like 100 harnesses on a super complicated driver. It's just not very fun. So it turns out that there's a good way to do that, and it's coverage visualization. So if you've ever done like development on Windows or Linux and run a program and needed to do like performance testing on it, you've probably seen something like that graph on the right. That's a flame graph. It just tells you like this function executes for X% of your runtime of your program. So you know, if your decoding function or your sorting function is running in like O of n cubed time, maybe you should make that a little more efficient because you were really lazy when you wrote it the first time. This one on the left is a little uglier. So that's actually the output of Clang's coverage metrics, and it tells you how many times each branch executed. But that's kind of ugly. It's not actually, in my opinion, like it's a level above the JSON, but it's not like 3 levels above the JSON to where most people would want to look at it. So we kind of want to aim for something more like the one on the right, a little bit more GUI based, a little bit easier for people who are used to working in Visual Studio and things like that to use. So we have a few options. We can use LVM's profile data or profile raw, whatever the format is that you're using. And that's emitted very easily. You just run a couple of, you compile with a specific flag, you run your program, it outputs a couple of files, and then you run this LVM coverage show, which will give you that kind of nice output on the right. It tells you how many times each line of code executed. It'll highlight ones in red if they didn't execute at all. So that's the kind of information we're after. But we're trying to support everybody with this. So not everybody is super comfortable in the command line. Not everybody is able to use LLVM for their software, especially on Windows. That's a big thing. A lot of people are restricted to using Microsoft's compilers. So this isn't a perfect solution, but it's getting close. One problem with this as well, if we're trying to build this format into tools, is that this format has no specification. You have to just go into the LLVM code base and read it all and say, all right, what's this weird binary format that tells me what the coverage is? It's not like incredibly complicated. It's like numbers and lines and stuff. But it's not super maintainable if every time LLVM changes it, you need to go and look at the diff of a bunch of source code instead of just looking at a changelog on a document. So that's not super great. But it does have all the information we want. So basically what we're after is number of times each line executes, whether a line executed at all, how many times each branch was taken or not taken in our program. That includes like loops and if statements and stuff like that. And then LLVM has this interesting one, which is modified condition decision coverage, which tells you for all of the like separate predicates in an if statement or a while condition, how many of those actually influenced the decision of the branch. And it turns out this is not that useful for development purposes, but it's very useful for security testing purposes, because you can tell what variables in the program are not getting flipped or are getting flipped to affect your control flow. So if you can say, all right, this particular variable is never getting modified to influence the direction of this branch, maybe we need to add some fuzzing or a test case that does modify it and see what happens. So that one's super useful, but not a whole lot of documentation about it. So there's another tool for the GCC suite of stuff, and obviously this won't really help us on Windows because nobody serious, unfortunately, is using like MSys2 for their development at work. But they have a couple things that are a little bit nicer than LLVM's system. Very similar stuff, almost exactly the same compile command to add the instrumentation that you need to output this data. You run the program again, it produces a couple of binary files, and then you run this gcov format, which actually in this case produces a readable file, but it's basically just the text of the code output. So we're slightly better than LLVM in that respect. We know what the format looks like, and it's probably not going to change. It's just code with a couple of annotations on it. But we're still not quite to a format that we can really use and output. So it turns out there's a tool that actually runs after gcov called lcov. I don't know what the L stands for. If somebody knows, feel free to raise your hand. But basically what this does is it's mostly intended for translating the gcov data to HTML. And we're getting back to our key objective of reaching a GUI, where basically we'll translate this to HTML, and then you can just view it as a web page, and you get a pretty output of all of your code with everything highlighted. Nobody has to run anything in a terminal. It's all platform independent. You just send somebody something, and they open it in Chrome. So super nice. You just have a very simple text format. That's over here on the right, and then down at the bottom is the annotations of what all of those records mean. But it tells us almost all of the same stuff as the LLVM and GCC coverage data. It tells us all of the branches we hit, all of the lines we hit, how many times we took each branch, how many functions have been covered, how many functions are not covered. The only thing it's missing is that MCDC stat, which theoretically you could add to this, but it's not in the specification. And theoretically you can also calculate from this if you work really hard. So I basically said, all right, that'll do. We'll use that. And our next task is to integrate into our fuzzing tool while it's executing and have it be able to observe what's happening when the program runs and output this format so that people can view this instead of anything in their terminal. So same example as before, but this is a web page that you can bundle up and send to somebody. It tells you all of the line coverage, function coverage. Not pictured here is like for each directory, it'll give you a list of functions as well, and then that's recursive. So if you have a code base, super huge code base, you can navigate through it easily, figure out what your spots all of your fuzzers are missing are, figure out what spots they're hitting, maybe variables that aren't covered, and so forth. So shop this around to a few Windows developers. They said, this looks great, please do it. So that sounds good. But we kind of need something to work with this format. The official code base for it is written in Perl, which I personally don't really like or understand or know in any way. So I wrote a little library for Rust, which I do like, and is also the language the fuzzer I was working with was written in. And we were good to go. That took like 4 hours. It's such a simple text format that it was pretty low effort. So we've got a library to work with lcov files in memory and then write them out to disk and then translate them to HTML. So basically what the fuzzer knows is the program counter of every edge. And in the program, when you're executing, if you hit a conditional statement, you have an edge. And one edge goes to usually the next instruction and one edge goes somewhere else. So if you have an if statement, it'll have the body of the if statement, or you'll jump down to below the body of that if statement. It kind of depends per assembly language, but in general, that's what the fuzzer knows, and that's basically it. It just gets that program counter stream and also the information of whether this program counter is an edge. So to go from program counter to a source line of code in this, obviously, once we've compiled the program and stuff, we don't have source lines necessarily. So we need to find an offset, which is the program counter minus the base of the object loaded in memory. So that'll be your ELF file, your PE file, whatever the case is. And we use debug info, either from the program or separately, which is usually the case on Microsoft platforms, to figure out what that base address and offset is. So we know what address we're at in the code. Debug info stores usually just a mapping of address to symbol, or like base of address and size usually is what it actually is, and then you can figure out what the offset is. So the way we get that on a running Windows system that's running in a virtual machine is via virtual machine introspection. Basically, we reach in using whatever mechanism our hypervisor or simulator in this case gives us, and we ask for some memory contents or the value of a register, and then we use that a bunch of times to figure out where the internal Windows structures are, and then we use that to figure out where all of the objects that we have the debug info for, but we don't have their base address, are located. So let's talk about how to do that. So in the simulator that I was working with, and in most like hypervisors or system emulators like QEMU, you'll be able to read virtual memory. You'll be able to read sometimes, but not always, physical memory, because that physical memory is simulated or emulated. And you'll be able to usually read registers. Now, with QEMU, sometimes you can't read all registers. Things like virtual machine extensions and all of the registers for that are usually not emulated. They're passed down to the host operating system through KVM or something like that. So you don't necessarily have the ability to read all registers, but for our purposes, we'll just assume that you can. And on the simulator, this fuzzer I was working on was built on, we could also read MSRs, or model-specific registers. So on Intel and AMD platforms, there's like thousands of these model-specific registers, and they hold super specific stuff, like since the last time you read this register, how many system management mode interrupts happened. So things that you don't frequently need access to, but the system has some value in storing that data, and sometimes Intel sees value in allowing you to know what that register's value means. So that's basically model-specific registers. Some of them are super commonly used. So we'll talk about one in particular that's used for this. So we kind of have a roadmap for what we need to do using this capability. First, we need to find the kernel, because if we don't know where the kernel is, we're going to have a really hard time finding all of its structures. And we're mostly worried about kernel drivers for this, and kind of less so user space processes. User space processes coverage is kind of already solved, like we looked at with those compile flags, and MSVC has its own way to do that, even though it's a little bit less easy to access. So first, we need to find the kernel, and I did not know how to do this. All I knew was how to read some memory, same thing as the simulator knew. So I started by looking at some existing tools. A lot of people here probably, maybe show of hands, know about volatility. Okay, decent number. So volatility is a memory forensics tool. So if you capture an image of the RAM from a running system, you can use volatility to basically ask questions about it, like was some malware active in this system when I dumped the RAM? or what were all of the command line programs that were running, and what were their arguments when I dumped the RAM of this system. So to do that, it does a very similar thing to what we need to do. It scans through memory, it finds the kernel, it analyzes all of the structures of the kernel to find all of the information that it's able to give you. For the command line program example, it'll scan through memory until it finds the list of processes that's currently loaded. It'll traverse through those processes, and each process in Windows has a member of its internal structure that says, here was the command line arguments to this program. So just read those, dump it out, and now volatility has told you what the command line arguments are. So I looked there first because I took a memory forensics class in college and I knew about it. And basically the way volatility finds the kernel is by scanning the entire dump of RAM for just like a pretty simple signature of what the kernel is supposed to look like. And for my purposes, this was not good because the simulator I was working on took like 2 or 3 minutes to scan through all of memory, and making it worse, the simulator let you put an arbitrary amount of RAM into the system. So like you could have a petabyte of RAM in your virtual simulated system, which would take a very, I didn't try this, but like 16 gigabytes took 2 minutes. So you can kind of do the math on how long a petabyte would probably take. But I needed it to be able to work for any amount of RAM, so this was not going to be good. But the thing I learned from that is kind of what the signature of the kernel looks like, and how to tell, like, if you have an address, is this address the base of the kernel? And we'll talk a little bit about that later. But the next thing I checked was libvmi, which was written by one of my coworkers and friends at Intel. And basically, this does the same thing. And I was a little bit miffed at this because libvmi is supposed to be used online. It's on a running system, but libvmi is designed to be used in a hypervisor like Zen or KVM, where reading memory is actually pretty fast. There's no emulation behind the memory. It's just go look at a physical address on the system you're already on. That's a pretty quick operation, and so they can kind of get away with doing that. So that still didn't work, but I compared the implementations of like checking whether a certain address is the kernel between libvmi and volatility, and I said, all right, these are pretty similar, so this must be the right way to do it. So again, a little bit of information gained, even though this didn't really work for my purposes. And then there's a third way to do this, which everybody online, if you search this problem, will suggest that you use, which is to just call ntquery system information, which is a function in ntdll on Windows, which will just give you the base address of the kernel for free, which usually isn't something that you get access to on Linux, so I was a little surprised about that. There's some permission stuff involved. You know, you can't do this from every process. You need certain privileges, but that's cool. The only problem is, since I am the simulator kind of in this situation, I'm not actually allowed to run code on the system that's being simulated. So this still didn't work, but another piece of information gained: A, you can do this, which is kind of crazy, and B, this function will give you a lot more than just the base address of the kernel. It'll give you like process offsets, process information, where certain things are located, and so kind of just learning from all of the options. This is like a very large call. It has a lot of parameters. And so just kind of learning the vocab of what all of the internal structures of Windows were from the documentation for this function was also super helpful for just Googling stuff to complete the rest of this project. So I didn't know anything about Windows. I learned a little bit about like what the kernel maybe looks like. I didn't really know what a PE file looked like, so like learning the signatures for that was good. So where do we go next? I've kind of asked the security community by reading through their GitHubs. I've kind of asked the security community by messaging my coworkers, but it turned out that like he had some copyright thing on libvmi, so he couldn't really tell me much about it at work because he didn't want to lose his copyright. So lots of silly roadblocks, you know. It turns out that game hackers love the Windows kernel. And if you've ever played Call of Duty, you probably know this because there are just a million hackers everywhere. And of course, not all of them are kernel hackers. Most of them just downloaded stuff that they paid like $35 for online to cheat in video games, which I still don't understand. But the people who made those exploits know a lot about the kernel because they need to circumvent anti-cheat. Anti-cheat, for those of you who don't know, runs with like the maximum system permissions, usually on Windows. It can read everything you're doing. It can write to any process. It can download every picture you've posted of your dog from online if it wanted to. I don't know who decided it was a good idea to trust game developers who, you know, very frequently have bugs where you like walk through walls or roll through the ground in Mario 64 if you've watched the Half-A Press video. Yeah, I guess we do that. And it turns out that people who want to circumvent those anti-cheat things know a lot about the kernel, because those kernel level privileges that the anti-cheat has need to be targeted by the game hackers so they can get around them. And so game hackers know a lot about like internals of Windows, all of the structures and stuff. So there's this website, unknowncheats.me, where people will just post full exploit code for like various versions of Windows. It's pretty fantastic. And they usually either won't attach any comments to it, or all of the comments will need to be Google translated, but you can get some good information out of this stuff. So like all of the structs that they use, I didn't know any of these, but they'll define all of the structs in their code. And the reason they do this is because these structs are not in any header file that Microsoft publishes. Sometimes they're in PDB files that Microsoft publishes, which is debug info for Windows. And nobody really knows whether that's intentional or not, but some of these structs have been unintentionally published. Some of them have been reverse engineered and just kind of understood over time. But those structs kind of coming from the cheats websites were super duper useful for understanding like where all of the pointers that I needed to get to the process list and the kernel module list, which are really the two things we're after, were located. So there's also a couple other good places that I found to get info. So this guy, Jeff Chappell, I have no idea who he is. I didn't read the bio. I just went straight for the kernel struct documentation part of his website. But it's like probably some of the best documentation I've ever seen. So even if you don't care about like Windows structures, if you just want to learn about how to write documentation for structures for a program, I highly recommend checking out this website. It's like mind-blowingly good. And he claims that he's never worked for Microsoft. He doesn't know anything about these internal structs other than just like public knowledge and stuff, and he just works from that. But basically he describes every field in detail, its entire history of what it's ever done for just about every Windows kernel struct that I needed to use for this. So thank you, Jeff, if you're in the room. And then finally, the one thing Jeff doesn't do is publish like a machine-readable specification of all of these structures across time. I didn't really care about like working for Windows 7 or Windows XP or anything like that, but I really wanted to work for every version of Windows 10 and 11, just because we have lots of machines running those at the moment, and usually if you're testing kernel modules, you're probably on like the latest couple years of releases. Although I realized the other day Windows 10 was released in like 2015, so that's almost a decade, which is kind of crazy. So there's this project, Virgilius project. I forget where they got the name, but it is on the homepage because I remember reading about it. And basically what they do is they've taken all of those accidentally or on purpose, we don't know, published PDB files from Microsoft, and they've extracted all of the structure definitions from those, ingested them into YAML, which was an interesting choice. I don't know why they chose it, but they're all in YAML, and posted it on their website, which is super helpful. Because the first thing I tried to do before I discovered this website was download an ISO for every version of Windows ever. Spoiler alert, some of them are very hard to find. Unpack all of them, which is like 30 terabytes. I have that much storage, but I had to clear out some Linux ISOs to make room for the Windows ISOs. And then extract all of the PDBs myself by downloading them. And that's actually where I got stuck, because that is a lot of bandwidth. And it was going to take like 2 months to download all of it, which was not really cool with me because I started writing this talk like 3 weeks ago. So anyway, I downloaded the YAML. So the first thing I had to do was translate this YAML. I did not want to work with it. I don't really like YAML personally. I don't know how everybody in the room feels. If you're a Kubernetes person, you're probably either like really cool with it or really not cool with it, depending on which like side of the Kubernetes spectrum you're on. But I like writing Rust, as I mentioned earlier. And right now, they're in this weird like C definition in a YAML file. So the first thing I did was translate all of that to C from the Rust, because it was in C. It was just also in YAML. And then, of course, if you try and compile that C, it's not going to work because you have a bunch of structs defined later, which are part of structs defined earlier. And it turns out there's a very simple way to solve that. You just topologically sort all of the types, which actually is where the YAML came in handy, and I suspect maybe why they used it. So I have to give them a little bit of props, even though I'm still confused. After that, you've got C that compiles with maybe like 1 or 2 manual tweaks because there's some typos, but I was actually pleasantly surprised that I was able to just compile this C code like with GCC on Linux from like automatically extracted Windows struct. It was pretty cool. And then, of course, because Rust is awesome, we just have a tool that you can run that'll translate that all to Rust. You don't need to do any manual work. So that's kind of what that looks like. Here's the YAML on the left, very ugly. Here's the C in the middle, okay. And there's the Rust on the right side, which is beautiful. All right. So I mentioned that I needed every version of Windows earlier, and the reason that I do is because every time you have a new version of Windows, like for whatever reason, and I'm not sure why they did this, all of these fields get shifted, resized, reordered, and this will be like between build versions. So like Windows 21.1 has like 3 or 4 builds, and all of them, the structures that you need to do this to are like completely different. And so in order to resolve that in the simulator, you need to be able to figure out what version of Windows you're looking at so that you know what version of the struct you're looking at so that you know what the heck you're looking at. So first thing we need to do is check the Windows version, and thankfully this is very easy. And Microsoft, I really hope, never changes it. So there's a structure, and this one doesn't change that much, which is good. Like, fields at the bottom of it change, but the fields we care about have never moved, which is great. And I learned that from Jeff Chappell's website, so one of the reasons you should check it out. There's this struct called kuser shared data, and it's always mapped at the exact same virtual address in every address space while Windows is running. So any process or in kernel mode, you read this address, you're getting kuser shared data. And from that, you can get the major version, which is right now always 10, the minor version, which is right now always 0, and the build number, which is the thing you actually care about. And that'll tell you which version of Windows 10 or 11. Major version is 10 for 10 and 11, which is a little confusing, that you're looking at. And I figured that out by just running a bunch of Windows systems and looking at this struct in all of them, because people said stuff online, but I've been burned before by just reading unknowncheats.me and running code from it, so I just wanted to make sure. So we read that struct, we get the build numbers, and now we know what version of every other struct we're going to be looking at. So we build that into our system. Next thing we need to do, now that we know like what the kernel structures are and what their fields are and how big they are, is we need to actually find the kernel base. And so to do this, I think I already mentioned, we don't want to scan through all of memory. We could, but it'll take a very long time, and it might take a very, very long time. So what we want to do instead is find some code pointer into the Windows kernel, and we want to just scan backwards in memory, and I have a diagram of this. We want to just scan backwards in memory until we find the base of the kernel using those signatures that I extracted from libvmi and volatility3 and didn't write myself until I realized that I needed a couple more checks because, oh, it's not on this slide. Oops, sorry, we'll get there soon. All right, so there's 2 ways we can do this. One is the interrupt descriptor table. So on all, and this is x86 specific, so I apologize to the ARM enthusiasts in the room, but I haven't looked at ARM Windows yet. But there's this thing called the interrupt descriptor table, which tells the processor anytime an interrupt happens, you go to this table, and depending on what the interrupt was, there's a bunch of function pointers for you to run depending on what the interrupt is. So general protection fault, you run this, this particular function which handles that. Or divide by 0 error, you run this other function. And you can set these all to the same function, which will effectively give you like a single entry point for handling interrupts. Or you can set them all to different functions so that you just handle them one by one, depending on what that interrupt is. Now, this interrupt descriptor table, as of like one of the Windows 10 builds that I'm forgetting, it's like 19 something, Windows has introduced a feature called Kernel Virtual Address Shadow, KVAS. And basically what that does is they're trying to move any pointers that used to be into the code section of the Windows kernel into a different section in memory, which is sometimes adjacent to the kernel and sometimes not adjacent to the kernel. Although, as we'll see, it kind of doesn't matter for our purposes, but for like finding ROP gadgets and stuff, it really does matter. And that new code section is just called KVAS code, and that's, like I said, either located adjacent to the kernel or kind of near it, but separated by some memory range. So the second way, which actually doesn't work anymore, and that's why we're not going to use it, but it's worth mentioning, is the MSR II32 kernel GS base always points to a specific structure called the KPCR, and that KPCR contains a bigger structure, it's just tacked onto the end of it actually, called the KPRCB, kernel processor control block, and that contains a pointer to the current kernel thread. And so of course, if you can access the kernel thread, you would think there's probably like a reference to the entry point of whatever that kernel thread program is, and that used to be true and is no longer true. There's now no code pointers from that K thread into actual code of the kernel. So you have some like data from the kernel, but you don't have a code pointer anymore, which is unfortunate because that's actually a really nice way to do it, because it'll just give you a direct pointer into a known place in the kernel. And now we just have to find some known place in some memory that's not the kernel and try and find the kernel based on it. Luckily for us, it turns out that's not actually that hard. And this is kind of what either of those processes look like. If we take the IDTR, which is the interrupt descriptor table register, the base field of that register basically just straight up points to the interrupt descriptor table wherever it is in memory. So that's very easy to find. That'll work on like QEMU. Any simulator essentially has to have that IDTR. And then the second method, using the IA32 kernel GS base MSR, that'll point to the KPCR, and then the IDT base field of that structure points to the same place as the IDTR. So if you were in a situation where you could only read MSRs, but you couldn't read the IDTR, you could at least still find the IDT from that first method. Or sorry, from the second method, if you could only read MSRs, which I don't think anybody else will ever end up in that scenario, but if you do, now you know how to do this. All right, so once we've found the first entry of the interrupt descriptor table, that's going to be divide by 0, actually, is the first entry of that. So we'll take the code pointer to the handler for that, which is a kernel system call called KI divide error fault. And this used to be in the kernel. It would just call straight into the kernel code at that location. Now all handlers externally, entry points into the kernel, are in this KVAS code section, which has like a swap.gs instruction to like change the page mappings, and then it'll jump to the actual handler in the kernel. So unfortunately, that means we would have to like disassemble that handler to figure out what its code pattern is that it's jumping to in the kernel. We would need to use, like, we'd need a single step over that swap.gs instruction to get a new page mapping so that we could translate the addresses correctly to find the kernel. It's just kind of a mess. And so what we do instead is we just walk backwards in memory, because we know there's going to be some memory between KVAS code and the kernel code, but it's not going to be massive. And so we can pay a small performance penalty for a lot of simplification of this process by just doing what's called a scan back. And the unknown cheats people love this. There's like 100 different code examples of how to do this, and they all do it the same way and seemingly don't realize that 100 other people have posted the same code. So on versions below 19,000, pages are 4 kilobytes aligned, and on above 19,000, they're 2 megabytes aligned, which I think is large pages, but not huge pages, if I'm remembering correctly. So we have a start, that's our KVAS code pointer. We have a step, and now we need an end. So this is kind of the tricky part, is making sure that we'll go far enough with our scan, but we're not going to, like, for some reason, if we've picked a bad code address, we're not going to like go all the way to the 0 address, because then our system would walk backwards for like 20 minutes, and then it would say, all right, we reached null, so clearly there's an error. We probably want to fail a little faster than that. So our stop address, we basically just truncate our start address to like the nearest gigabyte and assume that'll probably be good enough. And so far I haven't seen it fail on any amount of RAM, so I think that does work. So, yep, once the page we look at is the kernel base, then we're good. We found the kernel. So that's really the hard part. But how do we know? Oh, yeah, here's the code for that. Probably nobody cares about this, and it was like 11 p.m. when I put this in the slide deck. But it's pretty simple. So we just take a build number for the kernel, and then get the IDT base, scan backwards, and check if page is kernel. And that's kind of the part that I took out of volatility and libvmi. So we basically just do a bunch of checks, and if any of them fail, then it's not the kernel. And if we get to the bottom, then we're good. So first we make sure it's a PE executable. That's kind of the first check. And then if it is a PE executable, we make sure it's also an NT executable. Because it turns out that Microsoft, for one reason or another, I don't know if this is on purpose or not, has put a bunch of like magic bytes for PE executables just kind of littered through the kernel at various places. And so you'll run across something and it'll say MZ, and you say, all right, great, I found the kernel. And then you try and use that, and everything is total garbage because that MZ byte is not actually the kernel. So you need to do a bunch more checks to make sure that you're not running across like either a fake header or an unintentionally fake header. I'm not sure which is the case. So once we know this is a PE, we know it's a NT version PE, so PE 32 plus, then we make sure that it has an optional header. We make sure the export header of the optional header exists and it has like a valid size. That's a good sanity check. And that's the point where there's no longer any fake stuff. So there are some fake structures that will satisfy the magic check for the DOS header, the NT header, the optional header, but there aren't any that'll satisfy that export header check. So once I got to that point, I didn't see any false positives pop up, which I thought was kind of interesting. That seems like a lot of steps to set stuff up if you're not doing something intentionally, but I'm making no accusations. So after that, then we find the name field of that export directory, which just tells other programs like what this program is. And we just make sure it's called ntosskernel.exe. And if that's the case, then you found the kernel, or you can be pretty sure that you have, unless somebody is really messing with you. All right. So we've got our kernel base address. Now, we don't know anything about what's in that kernel yet. We just know what the base is and we know what the version number is, but we don't know where the structures are and we don't know what they're called. So we need to get some debug info both for the kernel and for all of the applications and drivers running on the system. So we need to grab PDBs, and luckily Microsoft very helpfully has what's called a symbol server. So if you know some specific information about either a DLL, driver, or an executable, you can just download, if Microsoft has it and is willing to give it to you, you can just download the debug info for that file. Super helpful, helps a lot for debugging, and really helps us out for this because we couldn't do it without that information. So kind of similar process as before. We read the PE structure, and PEs have something called a debug directory. And some of those debug directories are in this CodeView 7.0 format, which apparently is PDB. Microsoft actually has an open source PDB specification repo on GitHub, which is archived and not being worked on. So maybe download that before it goes away, I guess. I don't know what the archive means. Then once we find that CodeView 7.0 information, there's a header for that specification that says, like, here's the file signature for CodeView, and then here's a GUID, or a globally unique identifier, which is just a string of numbers essentially, which uniquely identifies that file. And then there's what's called a file age. I don't know what this means. It's just a 0 or a 1, so I guess it's like not old or it is. And then there's a file name. So if we have all of that information, we can just download the PDB information for that executable. And then we can also just download a copy of the executable too, which is useful because it's actually not super efficient to copy executables out of a simulation, and you don't always necessarily want to do that. It's sometimes better to just download the fresh copy of the executable from the symbol server as well. And we can do that by knowing the executable file name, which for For the kernel, we actually don't know until we check that export header, because for different distributions of Windows like IoT Core and ARM, there can actually be different kernel executable names that you might run into. So you actually do need to check this. You can't just assume it's ntosskernel.exe. All right, so once we know that information, we can download the PDB file, which has all of our debug information, and we can download the executable fresh from the simple server. And this is what that process looks like. All right, so we've got executable image, we've got some headers. Those headers have information. This will probably be easier looked at like after the talk if you're really curious about it. Hopefully it'll be visible on YouTube. But the things highlighted in red, that time, date, stamp, size of image for the file header, and then the signature, age, and file name for that code view signature are the only things we actually need in order to get the debug information for our kernel. And that'll actually be true of all of the drivers and the executables running on the system. We just do this exact same process once we find the bases of all of those PE images loaded in memory. So we didn't actually need to do any extra work to find the PDBs for all of those things either. All right, so next thing we do, once we have the kernel PDB, we can use the base address that we already found for the kernel and the PDB info to figure out where in memory various structures in the kernel are. So one of those is the list of processes, very useful. And the other one is the list of kernel modules, also very useful. Those are actually the only symbols that I needed to use, but if you wanted to determine more stuff about the kernel from this, like I was only interested in getting base addresses for things for coverage purposes. But if you wanted to like analyze a system for malware and maybe like find kernel modules which are not in the list and figure out maybe if you have a rootkit running on your system, you might want to use more symbols in the kernel to figure out extra information beyond what I've done. So a little bit about paging. Basically, when a process is running, it's called paged in, and everything in that process is mapped. And then when you switch to another process, the stuff in that process gets mapped, and most, but not necessarily all of the stuff from the first process will be paged out. So if you try and access its memory location, there will be either nothing there, or it'll be something different because your current process has something else mapped. So because that's the case, there's some information specifically like the file names for processes that are paged out, which are not actually mapped for those paged out processes. And so it's kind of hard to build like a full list of the file names and all of the information and grab all of the stuff that we need to download PDBs for all of the paged out processes. So what I did is basically just said, all right, let's just grab it for the current paged in process. And then every time there's a change in the page maps, which is a write to control register 3 on x86, we'll just refresh and we'll just grab the new current process, unless it's the same as the old one, in which case we can kind of optimize and not worry about it. All right, so to get a process's information, basically what we do is we grab and this is for the current process. So we'll grab that kpcr, kernel processor control structure address like we talked about earlier. So we actually need this MSR whether we use the initial IDT method to find the kernel pointer or not. There's a couple other options for grabbing this address. We could also use a symbol in the kernel, which is the loaded processor list. For some reason, I had some trouble using the in-order process links from the kernel to find all of the processes. Wasn't able to like replicate it with other VMI systems on older Windows, so I don't know if something has changed in new Windows and that's not an option anymore, but I didn't explore it any further, so you can go home and double check my work. But yeah, so basically we read this MSR, grab the kpcr and therefore the kpcr RCB, grab the current K thread, which is the kernel thread information for a process that's running. That K thread has a pointer to what's called the E process, which is like all the process information. Like here's its priority, here's its process identifier, here's its name, here's, importantly, all of the modules that are loaded in that process. So there's a linked list for each process that has all of the modules loaded into it. And that's like if you have a exe and it loads 50 DLLs, all 50 of those DLLs will be in that list. So this one, I actually think the graph is a little easier to look at. So we go from register to kPCR to kthread to eProcess. We need to grab that field directory table base because that's actually the base of the page table for the current process. So we need that actually to do the address translations. So once we have that address translation information, we can grab all of the rest of these fields using that address translation, because otherwise we would just get like garbage because it's not paged in or mapped. So we grab the file name, we grab what's called the PEB, and then over there on the right, you can see that arrow points back to itself. That's just a linked list of all of the modules for the process. That gives us our file name, our like PDB GUID information that we need to download the debug info for that module. And we need to do that for every process once we see it in order to have like full coverage of it, because very frequently the actual executable is going to be pretty small and most of your functionality will be in DLLs. All right, so once we've done that, we'll have like the DLL base address for all of the modules loaded in the system. We'll have the entry point, we'll have the image size, and from all of this, we can, sorry, I'm kind of running out of time, so I'm going a little faster. From all of this, we can build lookup trees. So basically, for all of our modules, we take the debug info, and we get all of our symbols. From all of those symbols, we have a like base address of that symbol and a size. And so from that, we can construct a range, which we can use whenever we have a program counter during our execution. Remember, that's all our fuzzer really knows is program counters. We have that program counter. We can figure out what range we're in of addresses, which will allow us to look up the symbol. And from that symbol in PDBs, each symbol has a list of lines. And those lines also have base and size, and we can look up our address in those ranges of lines as well. So just using our program counter, we can now say what line of code are we on, what function are we in, and that's actually all of the information that we need to construct that LCOV coverage, which will give us that really nice displayed graph or listing of code for our users. So I used interval trees for this, which is a nice data structure for range lookups. It's really great for a lot of like reverse engineering program analysis type stuff where you're doing similar like PC to something lookups, because they're almost always ranges. And basically what this is, it's like a specialized B tree where you have like linked list lookups, and you get really efficient queries, which is nice because querying is most of what we're going to be doing. We only build the tree once every CR3 write, but we have a query every like instruction that we execute. So it's a ton of queries. So log of n is really good, where n is just the number of intervals, which is not actually that big. You'll have like maybe a couple thousand lines that you need to look up over. All right, so from there, we correlate the coverage back from the PC. All we need to do is subtract the PC from the base address that we know we're looking at. Or we can do what I actually did, which is just store the lookups as PCs instead of offsets from base addresses of program objects. And that way you can just directly go, all right, PC, what's the range I'm in? Give me the line and symbol coverage. We build that into our fuzzer. Every time the system sees a write to CR3, we reload those ranges. And then we write that out after fuzzing's done to LCOV, and we have HTML coverage of all of our kernel code that we've been fuzzing. So Google search, it's kind of okay. You really need to know your search terms. And so it's really nice to find a forum or a Discord or somewhere where people can tell you, like, here's some actual information instead of AI-generated garbage. And then once you have that, you can actually find the stuff that you're looking for. GitHub search, which I kind of use to search through like volatility and libvmi libraries, is like currently amazing. Make sure you log in, and then if you learn how to use the search terms on GitHub search, you'll be able to find like almost anything instantly. Ask Game Hackers stuff. They love to talk about the cool hacks that they've done, and they'll just walk you through everything, even if they didn't post code with comments. And yeah, be lazy. Don't reverse engineer anything. I didn't reverse engineer Windows at all for this project, and I don't really think anybody should do it because so much information about Windows is public that unless you're like really looking for exploits, I don't think there's any reason to try. So, yep, that's it. Questions? think we have like 10 minutes, right? Oh, all right. Well, I have a flight to catch, but if you want to follow me on stuff, you can send me messages later, and I'm happy to help with any of this related things. But otherwise, thank you.
called Fog Ransomware. But before we get started, my name is Sam Mayers. I'm a security researcher at BSides Security. I mainly track ransomware threat actors, not really a specific one, just all of them, because all of them are really interesting. And then
I'm Bobby. I'm a principal security researcher at BSides Security, and I fill gaps, but I have a background in malware analysis.
So before we get started, let's just talk about ransomware as a whole. Ransomware is a malicious software that either blocks access to your computer or encrypts data until a ransom is paid. And nowadays, it's really just crypto. Yay. A lot of different ways ransomware threat actors get into the network. A lot of it is compromised credentials. There is phishing, brute force, tons of different ways. Different threat actors use different ways. Today, we're going to be talking about Fog. So Fog started at the end of May 2024, beginning of June 2024, so they've only been around for a couple of months. So far, there has been 32 companies that have been publicly shamed that they have been pwned. This graphic and data was from a couple of days ago, as in 10/22 that I made this, right? Well, I lied because this morning I had to update it because now there's 40 victims, unfortunately, mainly targeting the US, about 70% publicly known, right? Mainly targeting also education sector, which really sucks. A lot of it is under like elementary, middle school, but also we have secondary, college, and universities. Other industries are hit as well: finance, manufacturing, food service, food production, things like that, as well as victims in other countries like Canada, Australia, Netherlands, and other ones. So I'm going to quickly go over the kill chain right now of one of the examples of our IR team had to deal with. It's not the same for every case, not the same for every Fog attack, but it's similar, mainly the same TTPs we're seeing. So we have a threat actor. He uses compromised VPN credentials. They get that by either brute forcing it or buying it from an info stealer. So the info stealers are still a really big deal, and we need to handle that. That's a whole different talk, but let's deal with that later. Then the threat actor used pass a hash against administrator accounts, which subsequently gives established RDP access into the Windows server. RDP is Windows Desktop Protocol, which is a protocol that allows control of other computers remotely. And then they use SMB. SMB is Server Message Block, which is a message format used for sharing files and directories in a Windows environment. They use RDP, SMP, and BSexec in an attempt for internal spread of the network. After that, they disable Windows Defender, so Defender doesn't catch anything they're about to do. They download the ransomware, and they deploy the ransomware. They deploy it using a PowerShell script in a hypervised environment that encrypts VMDK files, which are virtual machine desktop files. They also delete backup Vim storage. They encrypt, which also delete volume storage and encrypt both local and shared network resources.
Okay, and then I'm going to speak a little bit about analysis of the locker file itself. So within the context of ransomware, a locker file is, that's the executable that the threat actors will drop onto your machine or your network once they get there. And when they execute that, that's what actually does the ransoming. It will encrypt all your files, it drops the ransom note, and then does all that stuff. So really important to understand these. As we had mentioned, Fog is not a very noisy group. The big boys like Lockbit and Akira and Ransom Hub, those guys they'll have waves where they'll own like 30 different companies in a weekend. Fog is very quiet. We're not really sure why. We're still kind of tracking them, but they'll have a wave of like 7 companies that they compromise. So they're hard to track because there's just not a lot of information and not a lot of samples. Around May, Arctic Wolf released a really good article about their analysis of Fog, and it's pretty comprehensive. They mentioned a couple samples and gave a couple of hashes, but unfortunately for us, only one of them was available, but we'll take what we can get. So we grabbed that sample, we took a look at it. The first thing we noticed is that, first off, AV companies, way back in May, a few of them were already labeling these samples as fog. So some researchers out there already knew what fog looked like, and they were tagging it. It's good for us because you can search in VirusTotal on that tag. And so we found, we did that search, and we pulled up 7 more samples. Hooray. I know this graph looks a little strange. Basically, what I'm showing you here is that from May to November, spoiler alert, we were able to find 20 samples. We believe that that's the entirety of the public sample set for fog. And I'm basically going to walk you through our long walk to get to from 7 samples to the 20. Okay. So with the 7 samples, we needed to study them and understand how we could possibly detect them and search for them. The first thing we noticed is that Arctic Wolf, in their blog post, they mentioned that fog will helpfully drop a debug file that has debug log statements in it, which is super weird, right? But it's for the operators. And what will happen is their affiliates who are using their ransomware, sometimes it doesn't work right, and that log file is to help them debug what's going on. It's helpful for us too, though, because it happens that in fog, they don't hide any of their strings. They don't encrypt any of the log stuff, and you can just search on them. So we started with that. The other thing that we noticed is that, so on the right side is a snippet of code from fog. I know you probably can't read it. That's okay. Really, all you got to know is that on the right side there, this is a decision tree. When it gets to the middle, if it turns out that if you ran it but didn't give it any parameters, it will just exit out. But if you pass it parameters, it starts doing evil stuff. You'll see it, if you can maybe squint your eyes, you can see at the bottom there, it will start closing services and killing processes and doing very mean things, right? But what that told us was that on any given fog sample, even if it doesn't run right, it will still drop the log file. So that is a good behavior to do threat hunts and searches off of. So we did that. Now, with the combination of the static search and the behavior search, we created signatures and searches off those in VirusTotal, and we're able to pull about 19 samples. So we're getting better. Okay. I want to dive into one of the samples that turned up here that was actually kind of interesting. So there's a zip file that got turned up when we did this search. This zip file had the fog ransomware embedded inside of it, but it was next to a bunch of really weird looking things. There's like a bunch of applications here. You'll see Cafion, CodeSector, Iperius. These are applications that do file transfer and backup facilities. And that's very common with threat actors that are deploying ransomware. They want to steal all of your data before they ransom it because they're going to double extort you. They'll do the ransom, but then they'll also have all your data and tell us, you got to pay us this ransom too, or else we're going to leak all your data on a leak site. So this is likely like what that stuff was. Also, there's an ntuser.dat file. I'm not a pen tester, but I took a class once, and I think the ntuser.dat file, it has recon information in it. It has like user information that you can enumerate when you're attacking the system. And then the locker was right in there, right? The other thing that was interesting was that on this specific system that this zip file was created for, they had installed an advanced IP scanner. And that caught my attention because within the Arctic Wolf report, they said that one of the utilities that they use is called Advanced Host Scanner. And this thing is named the same. And when I looked at the websites, they looked similar. So I think I'm pretty sure this was a fog threat actor case. And what this started to look like, this is basically the digital equivalent of a crime scene, right? Usually what happens is if ransomware is deployed, when the incident response team comes in, they'll package up the stuff they need to study and lift it off site, and then they'll study it there. And what we think happened was this organization uploaded that package to VirusTotal just to check it or whatever. And probably the most interesting thing we found is that VirusTotal had reported that this thing was uploaded from Brazil on 7/29. What makes that interesting is that we've been tracking fog cases, and there's no mention of Brazilian one. So this company either paid the ransom or is a non-publicly known case. And also the zip file, when it was uploaded, it matched the name of a software services company in Brazil. So super interesting finding, right? Okay, let's get back to the 7 samples. All right, so we needed to find something that sort of ties all those samples together. My colleague Sam showed me this really cool feature where there's you can ask VirusTotal, hey, show me, here's 7 samples, show me the similarities in all these samples. And VirusTotal will say, oh, like, here's this byte pattern that happens to be in 4 of the samples, or here's a byte pattern that shows up in 5 of the samples. Well, this search showed us 9 byte patterns that show up in all 7 of the samples that we were studying. which is super cool. And I'm sorry, BSides, I'm not going to draw 120 arrows and circles in there for you. But you know what, like you can imagine what it was supposed to look like, right? So those 9 samples, when we studied them, some of those byte patterns weren't related to anything. They were like strings or data structures within the file. But 4 of them, every time I saw them in any sample, they were very close together. And they were in, again, all 7 samples. So the first thing that tells me is this is a very interesting and important piece of code within FOG. So we made a signature out of it, and we started to study it. Now, to know what it was doing, we had to dive in and then like slowly work our way back out. So what it is in any given FOG sample, there's a section of code that, again, looks like this. I showed this graph earlier. What's happening here is the program starts, it unpacks its internal configuration, it reads it, and then it starts doing horrible things, killing services, killing processes, and all that. That's where those 2 log files are. That unpack part that unpacks the encrypted internal configuration, it looks not too bad like this, but there is one section in there that looks like this, and that's where those 4 shared code patterns are. And so this thing, those 4 shared pieces of code that are present in every FOG sample, it's related to the unpacking of its internal configuration. That's an important piece of code because that internal configuration tells FOG it's got its internal, the RSA key it uses to encrypt your stuff. It tells it like, you know, where it needs to go search on your files or on your system to look for stuff to encrypt. So important piece of code. So we made a signature out of it and ran it. And to our delight, it fires on all the executable samples. So it's a good signature, and it doesn't fire on anything else. So it's a safe signature. It doesn't create false positives. So this code, these 4 shared code bits are essentially a fingerprint for FOG. You can use this to like flag whether or not a sample is actually FOG. And then one really interesting thing happened. So we had these 19 samples that we found from previous searches. This fingerprint signature found one more sample. It's called unlocker. And if anyone's worked with ransomware before, typically what happens is after you've been ransomed, the ransomware gang will tell you, pay us this ransom and we'll give your stuff back. If you pay it, often what will happen is they'll send you an unlocker file that has your key embedded in it that will release your stuff for you. And this thing caught the FOG unlocker. The reason that we couldn't see it before with our other searches, it has the same debug log structure in it, but it has fewer log strings. We had previously used a threshold of 60, and this thing has less than that. That's why it flew under the radar for that signature. And then for behavior-wise, it drops its debug logger like the other sample, but it appends unlocker to it, which is why we didn't see it previously. But our fingerprint signature worked fine. The other really cool thing is that the unlocker, no AV companies as of yet are flagging it as FOG. So this is something that we found unique in the unlocker. So we're very happy with that. Yeah, the fingerprint works. And so what's fun about the fingerprint, you know, Sam had showed you things that we found that are, it's still firing off. We're still finding things like this week. Earlier this week, the fingerprint caught a few more unlocker samples. This one is specifically uploaded from Ireland, and we haven't seen any public reports of a compromised victim from Ireland. So it's helping us track activities for FOG.
Okay, so we're going to talk about some TTPs and IOCs, everyone's favorite part. I'm not going to bore you guys. I'll run through this fairly quickly. So initial access, they use VPN credentials like I talked about before. They either info stealer or brute force it. They get a Windows shell for the RDP and SMB, which we talked about earlier and go over in a minute. Persistence, they create a local administrator account to help excavate their privilege. They delete files. They disable Windows Defender, all the standard things with ransomware, but specifically they use something called pass the hash. Pass the hash is stolen passwords, hashes that will help them move laterally later, and they won't have access to, they don't need the clear text password, they just use that hash and enumerate it, and so that's one of the ways they use. For credential access, they brute force and password stuffing, as well as they steal passwords from password managers in conjunction with the pass the hash. They use port scanners and network scanners. They use RDP and SMB and other lateral tools. And then like every other ransomware, they stop services, they inhibit system recovery, and they encrypt the data. So a lot of tools that FOG use are open source tooling, or just native tooling. So they use Metasploit, they use network scanning and port scanning, which you could just look up the names. They are free. You just hit the download button and it downloads. And then they also use an open source script called Vim Get Creds, which helps them steal the credentials from password managers. So I just added a screenshot of one of the ransom notes that they did. At the beginning of their activities, their ransom note was called helpyourfiles.html, which was really interesting because most ransom notes are not .html, most of them are .txt. But now they're back to most ransom groups and they named theirs readme.txt. And then on the right, they pretty much, hey, we're FOG, we take responsibility, go to download Tor, go to this link, enter this code. I'm not giving anyone the code. And then you could chat with us for our own little chat room. And then let's negotiate / pay us the money pretty much. Yeah. And then for encryption file extensions, like I said before, at the beginning, they used .flock, but that was a little bit weird to track because that wasn't the name or anything similar, but now they're using .fog. And then this is a photo of their name and shame site. So they run 2 Tor sites. One is their chat room site, and one is their Tor name and shame site, which is pretty much any victim that does not pay the ransom. They get pretty much put on here, and you could just download their data. So it's really funny because they can't spell it's right, and that's been for a very long time, and I kind of want to message and let them know, but I think it's funnier that it stays that way. But yeah. So just some closing thoughts. Why should any of you guys care? Ransom's hitting every industry. Maybe not FOG specifically is hitting your industry, but ransom groups are hitting every industry everywhere, from technology companies to education to food service to everything, right? And if we're not educating and talking about it, it's gonna keep happening. And the biggest thing we need to do is stop paying the ransoms. This is feeding them, right? Once we pay them, it is pretty much giving them more money to operate. They operate as a company. They get employees, they buy servers, they buy all this stuff, and we give them money, they're able to increase their strength and keep on going. So if we stop paying them, first they'll stop doing it because they're not making money, and second they'll stop doing it because they can't afford to keep doing it. So that's just something we need to do as a whole. And I know you wanted to.
And then also, there's just a lot more things for us to investigate. We haven't done full analysis coverage of the FOG sample itself, so there's probably a lot of other cool things in there. And we also have a Linux sample for FOG too, which we haven't covered here. But you know, they use that to ransom your ESXi servers, which is super scary if it happens to your org. But yeah, we're a fairly new research organization, and so when the IR team that we support came to us and said, "Have you guys heard of FOG?" and we were like, "No," we had to like quickly pull together and figure out how to track and study these guys. And so this was the process that we kind of built out. We're excited to apply this process to the big boys, right? We want to study the like Lockbit this way, or Akira or whatever. And the other thing that we've noticed too is that in the past month or so, there's a bunch of really new ransomware groups popping up. There's names that we see. There was a name that I saw like 3 days ago that I had never seen before. So there's always new ransom groups. So having a process in place to really quickly get your arms around who these guys are, I think is very valuable. And if you want to study ransomware, come chat with us. We're easy to talk to.
And then lastly, unfortunately, our blog post was not able to come out today, but it will be up next week. So if you go scan this QR code, or if you don't like QR codes, you can go to that link. That is our GitHub page, and we have posted all of the YAR rules that we use, as well as all of the IOCs that we have found and gathered on our GitHub, and then we'll link our blog post, which goes way more into depth, as well as a lot more other fun things as well, and then also our contact. Does anyone have any questions?
Actually, a couple months ago, people that were starting to track the exchange of ransomware with the fact that it's cryptocurrency, banks are actually moving money. And if you reduce cryptocurrency,
To my knowledge, like, we have not. The big thing that we try to stress to both our customers and as a whole is don't pay the ransom. There's no guarantee that if you pay the ransom, they're going to give you the locker. They're not going to post it. They're not going to double extort. They're not going to do anything, right? You're just pretty much giving them money. They already got you. It doesn't matter. They could double extort you. So the idea is to just not let them, just don't pay. And I think that's just a systematic thing we need to change, but overall.
I think too, we've been discussing this within our team, but the other thing that we think is contributing to the rise of like smaller ransomware groups, the government, the U.S. government actually sanctions U.S. ransomware groups by name. So like Lockbit is on the sanction group, and so it creates this really bizarre situation where if you get ransomed by Lockbit, it's actually against the law for you to pay the ransom. Like you will get busted by the FBI for paying it out to get your stuff back. And that hurts, well, it hurts the customer, the clients obviously, but it also hurts the ransomware groups because then they can't get ransoms from US companies. But those sanctions are built off of just the name alone. So the way to get around that is you make a new name for yourself. And so we're thinking that might be one of the reasons why there's this explosion of new ransomware groups. But it's not verified, it's just something that we've been looking. Yes, you.
How different or similar are these groups to say Black Suit or Royal Locker that did CDK Global earlier?
So the one similarity, and we go over this in our blog post, is they're very similar to Akira. It seems like it's an offshoot of Akira. They have a lot of similar TTPs, a lot of similar tooling, a lot of things similar, but they do a couple of things different. I mean, the fundamentals of ransomware, they're all fairly the same. They get in, they encrypt your stuff, and they demand money. But those little things are what separates them. But yeah.
Thank you.
You're welcome. All right. I think we can.
So your example was for Windows, and then at the very end you mentioned something about a Linux
Yeah.
sample. So this is not just Windows only
Correct.
environments. Is it also OS 10 or Linux?
So the Linux samples that we've seen, we actually had a case where the Linux sample was what was used, and they're using it to attack ESXi servers, because there's a lot of cases now where on premises companies will be having a bunch of their servers just run from ESXi, and so if you ransom it at that level, you get all of the VMs that were running there. That's what that sample's for, and we're still sort of studying through that sample, and we'll update our blog as we understand it more.
So is ESXi Linux or is it also?
Yeah, at its base, yeah. So, yes, ma'am.
Oh, you got it.
We-
How many of your customers have mature enough BCDR processes that they can follow your advice to not pay the ransom?
I apologize, what's a BCDR?
Business continuity.
Oh, so luckily, yeah, sure. Luckily for us, we have, so for Beasley Security, our parent company is an insurance company that pays out cyber insurance, and they have all of that structure in place so that if something does happen to a customer, they have a huge Rolodex of contact books to help their specific clients do that. We don't have to worry too much about that. We're the research guys. We just bury ourselves in binaries and threat intelligence. So, yes, sir.
Well, I think at the macro level, not paying the ransom makes sense. At the micro level is where you run into that challenge. An individual company, they are, not looking at the commons. And so I think the really tricky thing here is like, how can we get organizations to recognize the things that they need to do to either prevent the event from happening, reduce the impact of it, and that's what I'm sort of interested in, like, as an industry, right? I mean, we talk about the not paying the ransom and things like that, but how do we make it harder? How do we, right? I mean, so pass the hash, it's been around for what, 2 decades almost?
Yeah.
Like, we haven't solved that? It's
Well, and most of, unfortunately, so we support an IR team, and a disturbing amount of the IR cases that lead to ransomware, they're from stolen passwords. Like, you go to Breached, or you go to all those leak sites, and you buy a password, and then suddenly you're in Snowflake. I don't know if you guys remember the Snowflake breach from earlier this year. That was a bought password. They got in there from a password that they bought on some site for like $100, and then it caused millions of dollars in damage. So.
like, so you're telling me there's loads of VPNs that are still single factor, there's
Yes.
Yeah.
loads of environments.
hey folks, thanks for coming. It's really warm in here, so sorry. So thanks for like hanging out with me while I think it's winter, but I'm not sure. All right. So I'm used to moving around a lot, so if you just see me bopping, that's because like I'm one of those people who can't actually stand still, so I apologize in advance. So who am I? I'm a principal security engineer. I work at a big cloud provider. You've probably heard of them. I actually used to work at a different cloud provider, so I just move around cloud providers, I've decided. That link is not super helpful, I'm realizing, but I did an interview with TLDRSec about what it's like to be a principal engineer in security. So if that's your path, like go check them out. There's maybe 10 or 12 of us who talked about our journeys. I like the security community. So I come out and talk with all you folks, and I actually help run security conferences. How many people are here from Portland area? Okay. How many people are here from Seattle? All right, awesome. So hi, Seattle folks. Like, I'm also from Seattle. I'm one of the organizers of BSides Seattle, so feel free to come up. And if, like, seriously, we're just as cool, please come up. We'd love to see you. So why this talk? I've worked at a lot of different companies. I've seen the same sort of, like, bad behavior, if you will, and, like, pitfalls that we all run into. And it's kind of funny because you don't even realize you're in them until you're in them, and you're like, wait a minute, this feels wildly familiar. So I thought I would do this talk. Normal disclosure, these are my opinions, not my company's. All right, so the first one, technology will solve all the things. I mean, how many people have like been pretty excited by all this AI stuff? And do you think it's gonna solve all the things? Right, okay. So my point is like we often say, oh, we have this problem. I'm just gonna go get a tech solution. I actually saw a job posting the other day that was like preferred, it's something about like their preferred requirements, and they were like, the person solves problems with tech, not process. And I was like, oh, wow, I wish them luck. So what does this ignore? It ignores the humans and the processes. Like, I know that's not the sexy stuff. I know we're all really into tech. That's why we work in security. We like technology. But guess what? You gotta deal with the humans and you gotta deal with the processes. You ignore those, your tech solution is pretty fragile. So like, let's say you find yourself and you've like launched some tool, or you've, gonna build some tool, like the XKCD, and you're like, oh no, like this isn't working. Like, it's an easy correction, right? Like go and look and see like, okay, well how does this interact with the humans that need to interact with the tool, and like, what's the process? But I would say like, if you're gonna avoid this, don't start with, what's the tool that will solve my problem? Start with, what is my problem? And do like your actual root cause analysis. Like root cause analysis is this amazing tool that we can use for everything, right? But if we actually use it for solving problems, we'll actually get the right solution versus just the easy solution. Okay, does anybody know what I mean by NAAS? Anybody want to guess? So what I usually call it is know as a service. And I think security pros are awesome at this. Like, dev team comes, we built this cool thing, and we look at it and we're like, no. And they're like, okay, but why? And most of our response is just like, well, you did this wrong, you did this wrong, you did this wrong, you did this wrong, like you didn't follow this checklist, you missed this policy, no, 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 no. Okay, but here's the thing. Like, it's a negotiation, right? You want the dev team to push something secure. At least, I really hope you do. They want to push their feature, product, new whiz-bang thing. We just talked about AI. So how do you meet them in the middle? Like, if you've ever studied negotiations, there's something called your best alternative to a negotiated agreement, otherwise known as your, like, BATNA. Like, know that before you talk to the team. Like, how do you get them to meet you in the middle? So we really can't do no as a service. Like, it's my running joke, like, because I do think we're actually really good at it, by the way. But we can't do that, right? Security is a partnership, unless you work, like, even if you work at a security company, I guess if you work at a security consulting firm, and everybody else around you is just security pros, maybe you won't run into this. But I don't think that's the vast majority of us. The vast majority of us work with, you know, devs, product managers, program managers, marketing. There's so many other things that I'm blanking on at the moment. So just remember, like, this is a partnership, right? Like, go in with that. And, like, you just don't, like, my biggest recommendation is, like, if you're about to say no, just say no, but. And give them an alternative, right? Like, no, you can't release that really awful product. You really can't, you know, have passwords and make clear. How about you do this instead? Like, give them a solution, right? Don't just say no. Because we've got to shift our mindset away from this. And, like, I do want to say that I do think the industry has a bit of a reputation, and a lot of people have a bit of a reputation of being this way. So, like, my call to action is, like, let's be a little better. All right, so how many people have a security review process? Okay, how much of it is self-attested? Like, how much does the dev team just go and do in a hole by themselves? How accurate do you think the thing you get back from them is? Like, this is the problem with self-attestation and checklists. I just don't think they really do a lot of good, right? Like, they're easy. They're wildly easy. And to be honest, if that's all you got, because you're super scrappy and you're a team of like 2 or 3, like, start there. But don't stay there, because we're not going to get the data we need from the dev teams to help them be secure. So my correction, or my avoidance, is automation. It's actually really interesting. Someone was presenting a new proposed program at work. And I was reading through it, and be like, this is weird. Like, where's the automation? Like, there was no reference to it. It was just like, we're going to have these people fill out this checklist. And I was like, well, I mean, neat, might be helpful, might work, might get us somewhere. But I actually think a lot of it could be automated. And so I would start with, like, what can you automate and what can't you automate? And so, like, that will really help you understand where you have telemetry gaps and where you need to go address those. One of my favorites in security. Everything is urgent. Nothing is urgent, by the way, if everything's urgent. Like, it's just not possible. So I actually look at this as the struggle between reactive and proactive security. And so, obviously, if you're in the middle of an incident, you know, focus on that. Like, focus on containment, focus on, you know, your incident response. But for the most part, I think we tend to react versus try to prevent or protect. And I know we've talked, like, in the industry, we talk a lot about shifting left, right? Like, we've got to shift left, which, by the way, if I ever do a talk on expressions I don't like, that's definitely one of them. But I do think, you know, a lot of what we focus on is just like, we're reacting to these constant events. Like, if you're in incident response, you're getting inundated, right? You're getting lots of detections. There's like logging alerts, there's monitoring alerts, there's, you know, alarms going off. Like, how do you actually get proactive? And that's why you need, like, not just incident response. Normally you actually need a full team, but if you don't actually focus on prevention, you're just gonna keep reacting. You're gonna keep reacting. You're just gonna keep reacting. The other thing that I think is kind of tied to this is that security people like to focus on threats, vulnerabilities, and issues. Like, it's kind of interesting, right? So what'd you find? Like, you ask somebody, like, what interesting things did you find in the threat model? And they'll tell you all the things. Okay, cool. What are the detections find? And again, they'll tell you all the things. If you have bug bounty, what did bug bounty find? Oh, all the things. But the business doesn't care. that we found vulnerabilities and threats and misconfigurations. They care about risk. And so when we hyper-focus on the things we found versus the risk to the business, we're not actually showing the business why we should be in the room. So that's when I say, like, what security cares about versus what the business cares about. I've come into a lot of security teams, and I've seen that exact behavior over and over again. We're reactive, and we talk about things that no one cares about. I mean, literally, that sounds terrible, but I don't actually think the business cares if you've found 100 cross-site scripting vulnerabilities. They want to know what the impact to the business is. And if you can tell them that, whoa, totally different conversation. Last year I was here talking about shared language and understanding. And so I think this is where it gets really important because, again, we're all security pros, or we want to be security pros, because there might be some people in the audience that aren't in security yet, right? The business is not, they don't understand what you're talking about. Like, I had a VP who once was like, can you guys stop with the inside baseball? I was like, inside baseball? And it took me a minute to figure out what he meant, but we're all talking amongst each other, explaining like what's going on, and he doesn't, you might as well be speaking a foreign language, right? And so we've got to remember that for the most part, we're there to support the business. And so if we don't use language the business understands, they can't really understand the value we provide. They don't understand the value we provide, we can't get headcount, can't get budget, and so on and so forth. So how do we like get around the whole everything is urgent, we're talking about the wrong stuffs? I do think this is a partnership with the business to understand scope, impact, and criticality, right? So if anybody does anybody in this room actually do risk management? Like, okay, we got one person, yay. One of the classic things in risk management is we talk about likelihood, and you'll notice I don't have that. I just don't know what that does for you. Like, there's a lot of incidents that if we reflect back and we'd say, what would we have rated the likelihood of this incident? I think a lot of us in this room would say, not likely, and yet it still happens, right? And so that's why I think you need to understand things like scope and blast radius and impact and be able to tell the business what that looks like. So how do you avoid all this fun shenanigans? I think my biggest thing is be wary of recency bias. If you have shout out to the gentleman who does risk management, like if you have a good risk management program and you say here are your risks, don't change all of them because you just had an incident. Like, be very wary of recency bias. It might actually show you that you've got the right idea, or it might actually put you on the wrong path. And I would say build a risk management program. And this doesn't have to be like, go buy a tool, go buy a bunch of humans. Like, this could be super lightweight. Just document the risks and share it with the business and see if they agree. And if they don't agree, keep having those conversations, right? You want to make sure that you are aligned with the business. Okay. Does anybody know what I mean by OPSEC? Yeah, can you want to like shout it out? No. Does anybody want to shout out what I think OPSEC means?
Operations security.
Yeah, but what does that mean?
What you do for security day to day.
Awesome. Awesome. Like, I wish I had a prize now. See? Dang it. I actually have a friend who talks about bringing prizes to talks, and I'm always like, that's such a great idea. And then I like totally forget about it because I have to drive distances and I always forget. Anyways, I will argue that OPSEC is almost never what we focus on, which is wild to me. Like, we're all security pros, but like, how many of us, do all the proper marking of our emails to say this is a confidential email? I'm gonna go with most of us don't. Or how many of us actually properly ACL a document? So you wrote a document, it's got all the risks. Who all has access to it? Like, the problem is, it's really easy, I think, to do the wrong thing. Like, it's wildly easy, right? So I think standards help here. Even though I'm not a big fan of policy, That should also be in words I don't like. But I do think standards can help here. So if you have a tool that actually will mark this for you, like go ahead and say like, you know, use the tool to mark the thing appropriately. If you don't, just tell people the expectation, right? Like when should you put something in an email? When shouldn't you put something in an email? When should you pick up the phone, right? Like we have to protect the business at the end of the day. And if we don't do this ourselves, the business isn't going to either. So what are my key takeaways? I think you have to reframe how you think about security at the start, right? We shouldn't be reactive. We need to be proactive. We don't want to show up with no as a service. We want to understand what actually is critical and important to the business versus just what we think is. If you find yourself in one of these pitfalls or headed towards one, just stop. Like, it's okay. Take the foot off the gas pedal, or in my case, off the battery pedal, because there's no gas anymore, and correct, right? Like, you don't have to keep going down a bad path. You have the opportunity to make a correction. And then, this might be obvious, but if it's not, security's iterative. We're gonna, like, let's be clear, we're all gonna fall into these pitfalls at one point or another. There is no way any of us are good enough to avoid it. There's just so much momentum in business that you're gonna hit some of these. And be okay with that. I mean, just remember, it's iterative, and we can keep going, and we can correct. And that's all I got, folks. So thanks so much. I don't know if anyone has any questions. I know that was like a very like quick tour of all the, I have more pitfalls. I just, for 20 minutes, I just want to pick on the ones I thought were the worst. Yeah, go for it.
So, I mean, you talk about risk, but how do you educate your risk management team, which is really a business risk management team, so contracts and things like that, and when you come to and say, okay, I want to get away from talking about the individual, hey, you found, you know, rodents all over the place. And this
Right.
How do you educate them to look at the bigger picture and say, you know, because they're on board, like they're risky, so they're on board with, oh yeah, that's risky.
Yeah.
But
If you can translate it into money, which is kind of what I meant by impact and blast radius, that tends to land well. So like, if we don't fix X, we'll have a total cloud compromise. If we have a total cloud compromise, this is how much business we forecast you would lose. And if you don't know how to forecast that, there's somebody who can help you on that risk management team. Because you explain, like, here's kind of the scope of what I think could happen. What would this cost us? And those folks are dynamite at that. And so that's been my approach, and it seems to work pretty well. Yeah, no worries. Anyone else? Yeah.
Talking about what you said about OPSEC, essentially, if you automate everything to take out the biggest threat vector, the human being.
Yep. I mean, and it may not work. Like, this is the one problem. I will warn you. Like, we're always like, oh, we can just automate everything. There's going to be gaps, right? But I do think this is an important point, right? Like, if you have the opportunity to turn on a policy that says you can't send an email unless you rank it, because there's all these rankings in email nowadays, which fascinates me. That makes it easier, right? Or you can't save a Word document or an Excel sheet or a PowerPoint or whatever your jam is without actually saying what is inside of it and why it matters, right? Yeah.
But on the operations side, this is my problem. And you see it today, I start looking up your supply chain. I'm attacking your third parties.
Yeah.
Getting into the build price. Okay, so you made it harder here, I'm just going to slide into supply chain and go where it's, that's my fear about automation. As we automate and we know less about the system, we're starting to we're building a complex system that becomes more fragile.
Yeah.
I'm not sure where those fragilities.
Do you have it looks like you have a counterpoint.
Right. What you're saying is very correct. I always get reminded of the T-shirt every time when I go to security conference. And I guess someone is there and says the S in IoT stands for security.
That's why I know as a service becomes like, oh,
would say, like, if you're going to automate everything, you probably need really good telemetry and really good alarming for something that looks anonymous, which is not easy.
Right, you shifted, the problem was, I knew, well, in a small shop, it's the old adage from like 20 years ago, I trust myself with root, I don't trust anybody else, right? So as you start to move to the automation program, you start to get worried about what you no longer can see, and then, am I getting enough alarms, and am I getting the right alarms? Like, yeah.
I mean, that might be better, though, than just, like, wide open access to all the things. I mean, there's a trade-off here, right? Like, it's kind of the classic trade-off between, like, security and convenience. And like, let's be clear, we're all security pros, so we're all here to solve hard problems. So I agree, it's a totally hard problem. So maybe you should do a talk on it in the future. Hint, hint, get up on stage. All right, anybody got anything else? If not, I'll let you go eat if that's of interest. All right, thanks, folks, really appreciate it.
my name's Keegan Justice, and this is a talk about building bulletproof AWS environments with secure CDK constructs. A little bit about me. I've worked as a cloud security engineer at GuidePoint Security. We're a full-service security consulting firm. I've been a DevSecOps engineer at several early-stage startups and started the security program from the ground up, all the way from idea to SOC 2 to live customers. Gone through several security audits. I have a bachelor's degree in management information systems from the local Washington State University, and I hold over a dozen active industry certifications, mostly in cloud and security. I guess I should give you a brief overview of security in the cloud, and then at the end I'll go over the code. Something that's really important to know is that there's a shared responsibility model in the cloud. This is not talked about enough. Their cloud providers are responsible for more of the physical security of the data centers, and then the customers are actually responsible for a lot of the configuration of their applications within the cloud. There's split duties, and it's important because you might be HIPAA compliant on paper. AWS may be HIPAA compliant, but if you want to become HIPAA compliant, there's actually additional steps that you have to do. There's partly cloud provider's responsibility and partly your responsibility. I'll give you a brief overview of the Cloud Security Alliance. They're a great platform, or they have some tools and standards for setting up cloud controls. They're highly recommended. They're an industry leader in determining controls for the cloud, but I'll touch on them very briefly. But when it comes to deploying the cloud, historically, before infrastructure as code, there was something called ClickOps, and it sounds exactly what you think it is. You go into the console, you click on, I want to launch an EC2 instance, I want to launch an RDS instance, and you do that. And it's good if you're just trying to set up something really simple, you don't really care about security, and you just need it really fast, and you don't need to reproduce it. But if you try to get specific configuration, you have to do it repeatedly. It becomes very easy to make an error. I would even say it becomes exponential the more things you add, because you're like, oh, I forgot to add this tag, I forgot to add this security group, I forgot to add the CIDR block, and stuff. You forget about things. And the thing about most platform as a cloud services in the cloud is that I would say misconfigurations are even more important than a pen test. It's these things that you forget about and you don't configure them correctly and you don't know about it, and that's where it really leaves you to be vulnerable. Which comes into infrastructure as code. This was the next evolution. It allowed you to have repeatable builds, automation, efficiency. You can put this into your pipeline, deploy your VPC, deploy your different resources, your databases, your applications, and just have everything be configured as code, and no more going into the AWS console, clicking on random buttons, and hoping that you clicked everything correctly. There were several iterations of infrastructure as code. A common one from AWS is CloudFormation. It's only on AWS. It's a native AWS service. If you have AWS support, they'll even help you with it. It's usually YAML format. It's also can be JSON. I've only really seen YAML in my professional experience just because it's easier to debug and comment out and iterate. But a huge downside was it wasn't really modularized, so you tend to not have dry code. You tend to repeat a lot of what you need to do. If you need like 5 EC2 instances or 5 databases and they're not all within an auto-scaling group, really what you're doing is you're copying the code and writing like your YAML is 5 times as large as it was before. Then there was Terraform, and then later OpenTofu. They're very related. OpenTofu was a fork of Terraform. This helped some of the dry components of code because you could actually do modules. You could modulize the code. It has its own DCL, HashiCorp configuration language. And this was a step up, but it was still because of the language constraints. You were limited in what you could do. Like it was a huge upgrade, but it was not perfect. Something that when you're looking at cloud controls, if we're going off a compliance benchmark, something we might want to look at is the CIS benchmark for AWS. Assuming you're in AWS, this talk is mostly for AWS, but you can apply this to other clouds, and I'll cover that a little bit later. But these are common things in the CIS benchmark in version 3, where You want all buckets to have access logging enabled. You want S3 buckets to all require SSL. And you want RDS instances to have encryption at rest. These are just like some standard stuff, best practices, and depending on your GRC policies, you probably want these enabled for every resource. Every bucket should have access. Every bucket should have SSL, or all databases should have encryption at rest. But when you're helping developers, it's a lot like herding cats. A larger organization, people will be deploying resources, and you'll be like, okay, all S3 buckets must have SSL. You spend a little bit of time, and you're like, oh, somebody launched an S3 bucket, and it wasn't using our template. Oh, no, they launched another S3 bucket using the console. And then all of a sudden, you're managing, you were 100% compliant today. 6 hours later, you're not compliant. And this is at startups, which aren't very big. At an enterprise, large organizations, it becomes almost unwinnable. You need a solution where you can actually have the developers deploy secure constructs and take into account what they're doing. And this brings us to a cloud development kit, or CDK. It was created by AWS. It allows you to use a programming language like TypeScript, Python, Java. You can actually use JavaScript too. My preferred is TypeScript, just because the static typing is very useful for this. I think that it's lightweight enough that you can write code pretty quickly, but it will come down to your comfort level. And then there's also Terraform CDK. This is where most of the aspects of regular AWS CDK are applicable here. However, Terraform CDK, in my experience, it's not stable yet. It's still in beta. They say use it at your own risk. I've used it. I would not use it in production. This may change in the future. With Terraform CDK, you can probably do this to Azure, GCP, IBM Cloud, any cloud provider. But at the moment, I would say stick with AWS if you're using CDK. CDK has several command line arguments or command line commands. Bootstrap is how you set up a project. Deploy, destroy, pretty self-explanatory. Bring up the stacks, destroying the stacks. Synthesize is pretty interesting. So CDK compiles to CloudFormation. So with Synthesize, you actually turn it into CloudFormation templates. So you can write all your code as TypeScript, have all this logic, and have a really robust validations, and then you can turn it into CloudFormation if you want it. Parts of a construct, so there's a scope. This determines what stack it's in, if it's a nested stack, where it is. It's usually this in JavaScript, TypeScript, self, and Python. By ID, this is a unique identifier. And then the props are really the arguments for a construct. So like if you look in CloudFormation, these are the properties that you're setting for the different platform as a service. When you're creating CDK constructs, actually just in cloud in general is how much access to give, because developers and engineers always want more access. They want to be able to deploy as much as they can. And as security professionals, we want to limit what they can do because we don't want an account to be compromised or privilege escalation or some sort of attack on credentials. There's multiple ways you can do this, but in AWS, one way to do this is to give them more access, give them the access that they want, or give them more access than you normally do, but then add service control policies or explicit denies. So they have an illusion of administrator access, but they don't actually have administrator access. So they say, oh, I have EC2 star. They do, but then we have an explicit deny elsewhere where they don't see, who actually denies all the stuff that we don't want them to do. It's a way to diplomatically give them access and at least make everyone happy initially. And also using a CNAP platform is pretty important, especially to look at IAM roles. There's a variety of platforms. There's even a vendor here, which is a CNAP platform. I highly recommend using a CNAP. But something that you need to look at when you're creating CDK constructs, and this will make more sense in the code, and I'll show some examples and I'll deploy, but it's how much documentation, how much self-service. So I've worked with multiple clients where they come up with these really abstract constructs. They're super secure, but they're not well documented, or they have to support them. So the more you deviate and actually make them more secure, more things that you change from default properties, the more documentation and more support you're going to have to do. Like I've seen enterprise clients where they have whole teams supporting, you know, their custom code where there's documentation, and you could get AWS support or another type of enterprise support if they just left them alone. So knowing the needs of a business, how big you are, your budget, and knowing when to do this. And then I've also seen knowing how to throw exceptions. So a lot of clients say we don't want to block developers, we only want to give warnings when there's a misconfiguration. Like we want to make something like if a developer does not choose S3 buckets instead of SSL, then we just want them to have a warning. The problem with a warning is it doesn't give an error code. So in their pipeline, in their GitHub actions, they see a green check mark. Most people don't go into the logs and look for the little line that says warning. They tend to just say, this is good, let's keep going. And what happens is that you really didn't do anything. You just had this very small message in the code, and it just is obscure. I would always err on the side of throwing errors in this case. You want to break things when things aren't secure. You want to basically force developers to create secure code. You can also, if you want to, you could overwrite things in the code, and I'll show that briefly, where you can actually go in and say, hey, developer did not choose encryption, let's always force encryption. The downside of this is it comes back to maintainability. You create these values, you're forcing SSL, and then the developer said, hey, I spent like 4 hours, why is this value always changing when I deploy? Aspect-oriented programming is pretty useful, so I'm not sure how many of you are software engineers, but CDKs is all object-oriented programming, and you can use aspects to actually plot without modifying the existing code to add additional functionality or overwrite values, and I'll demonstrate this briefly. There's also, you can do full tests. The unit tests, you would use whatever testing framework you use locally to test, like JavaScript, you would use Mocha, Chai, etc. There's a variety of testing frameworks for each language. However, these are not comprehensive when testing locally. You really need to deploy the code, so you need to do some end-to-end integration tests, usually by deploying the stack and then testing there too. I'll cover a couple of the different resources before I go to the code. So just an example of EC2. EC2, for those of you not familiar, is just the standard VM in AWS, but you could have logic where you can actually change the SSH key. You could say only allow these SSH keys, only allow SSH keys with these values, or do not allow any EC2 instance to be launched with SSH key. This is different than what you can do with Terraform or CloudFormation. You can use any, you can use regex expressions, you can do mix and match, you can basically put any type of code you want, and you just have a lot more robust and granularity with the details you can add to the code. You could go in and change CIDR blocks and say, do not allow port 22 with these CIDR blocks. If you do, throw an error in the code. And not that this is impossible with Terraform modules, but it would be a lot harder. It would be clunky, definitely clunky. IEM, what if you don't want these privilege escalation on IEM? What if you want to be able to have roles on EC2 not be able to have IEM pass role or create access key? You could say any IEM role with this trust policy to EC2, Lambda, etc. You could say throw an error if it contains any of these actions, or if it contains a star in any of these actions. So you can be very explicit in the control. API Gateway is another common service. So API Gateway is AWS's managed API Gateway, but it's usually not very secure by default. It's very hard to configure, but you could actually enable a lot of configuration. I'll demonstrate the code in a second. But you could say force authentication. Only authenticate with IAM or Cognito. Do not allow a exposed HTTP endpoint. Always put a web application firewall on it. Do not allow web WAFs or APIs without WAFs. Force logging to be turned on. Force cores to be turned on. Require SSL certificates. You don't have to do all of these, but if you're concerned about security, you're concerned about misconfigurations, you can mandate it. You can actually say, anytime somebody launches this, do not let them launch it. You're limited in service control policies because it's just JSON objects and you're limited in what you do. But if you give users explicit denies in the code, you can control this. And you can even do something similar in Kubernetes with EKS. There's manifest files, and I'll go over this in a second. But you could do something similar to Open Policy Agent in the code, and you can have granular control over the code. So let me go to the code. I have this CDK stack. I imported several CDK subjects. This is my vanilla S3 bucket. This is my secure S3 bucket. I have this inherent S3 bucket, and then I have this aspect that I'm applying. So vanilla S3 is very simple. This is all TypeScript. It's just an S3 bucket. We can see this is the scope. This is the stack. It's just the basic stack. This is the ID. And then props. I did not give it any props. If I go to bucket, we can see the different props which can be assigned to it. But I'm just giving it the default props. If I go to secure S3, I've now built on top of it, and I've added a KMS key. I'm saying whenever you create with secure S3 bucket, always give it the KMS key. We can even get more granular by controlling what's in the key, adding a variety of logic to say only allow certain access on the key, change the key policy. But I'm also enforcing SSL. I'm blocking public access. So now whenever somebody deploys this secure S3, it's a lot harder. It's a lot more secure. On top of that, we can actually do inheritance. So we can actually use this object and we can inherit from the AWS-based S3. And we can go into the props and then we can overwrite them. We can put them in here. And we could even say, if this is undefined, throw an error. So if somebody tries to create an S3 bucket with blocked public access and they don't define a value, we can explicitly say, do not continue, stop this, do not deploy the stack. And this is a way where a developer could go in here, and if they didn't supply this name or didn't supply some of these values, it would just stop. It would just stop. Then we have aspects. And aspect-oriented programming, we can apply an aspect. So here, I'm looking to see if it's a S3 bucket, and if a website is false, and if it is, let's throw an error. So this way, if this value is website equals false, we could say throw an error, and let me just deploy. And you can see I actually deployed this a little bit earlier, but now we are explicitly throwing an error because it's not a website. But if we want to go to warning, we can deploy. And then all of a sudden, we just get warnings. We can say if we want to continue, I click yes. And down here, you can see there's different levels to the CloudFormation stack. I can actually specify, there's different levels of abstraction, but if I go to CNF, it's usually the CloudFormation resource. I can manually say, if version is not enabled, I can override it and turn on enabled. So these are just a couple of ways. This is a 20-minute talk, so I couldn't talk through every construct, so I could only really cover S3 in some detail. But it's really about maintainability and choosing like, you just have so much more control over making secure constructs by default, and you can then hand your developers some of this code. They just import it and say, don't use regular S3, use this secure S3, use this S3 inherent S3. And then you should have security in default, and you spend less time going in and trying to manually change a bunch of resources what were created earlier. And then very briefly, I'll cover Cloud Security Matrix. This is from Cloud Security Alliance. It aligns with a variety of NIST controls, but if you're looking for a cloud security policy, that's something you can look at too. Any questions?
So you use this to deploy, I've started using CDK really to deploy Lambdas.
Mm-hmm.
Because I was using serverless, but then they've switched to really pushing a page-run model.
Mm-hmm.
And I had tested SAM, but CDK seemed like they've come a long way, especially for Lambdas. But you use this in place of Terraform now?
Yeah, well, SAM is built on top of CloudFormation. And serverless is built on top of CloudFormation too. They just have some abstraction and they have a bunch of plugins. So this would do I mean, I would think this is a replacement for Terraform. There is, but of course, with Terraform CDK, which is not ready yet. Don't use it quite yet. Use it when it's ready, but that's the same function. You can get the same functionality. When you deploy CDK, you get CloudFormation stacks similar to serverless.
Right.
It manages state the same way as CloudFormation. I would say, like, there are reasons to use Terraform. There's a large ecosystem. There's OpenTofu. But it comes down.
Well, I found it has limitations, like to get into like real coding problems. So like we've moved to a password vault, and I want to get rid of any secret in Terraform. So I got to pull from password vault, but it doesn't have. I mean, it does looping weird. It does lists and maps weird. Like you got to do all this abstraction layers and you're writing everything in JavaScript or TypeScript or Python. You're just using the native.
Yeah, absolutely. Like there's stuff like that where Terraform sort of falls apart. Like
right.
you're limited by the DSL. It gets really hacky.
The maturity level, I think.
Yeah.
With Terraform, and then you like.
Yeah, you can actually write actual applications, and you can actually package, like your front end code with the infrastructure, all using the same language with same linters.
Right.
It's just like you can add regular expressions. You can look through, and doing that in Terraform, I'm sure you can, but it's not recommended.
Yeah, it's you start getting nightmare.
Yeah.
At least that's what I found with just a simple thing.
And you can package Lambda functions up in here. I did not include that example, but you definitely can. And you can even write the Lambda function with the dependencies in CDK and bundle it up. So.
The thing I found is like Python's like the second family of CDK.
Mm-hmm.
Like everything I look is JavaScript and TypeScript, and then there's Python, and I'm always trying to figure out because documentation isn't great on Python yet.
But
there's not a lot of people that have examples of that.
with TypeScript is definitely the language I would prefer. It's strongly typed.
Right.
And if you try to do this in JavaScript or Python, you're going to run into some strange errors, and you're not going to be able to figure them out without the typing system. Okay. So that would be my recommendation. Java would probably be fine too. I think Java it's a lot of code for what you're trying to do here, but it's definitely do what you're comfortable with. Yeah, one more in the back. Yeah, in the AWS console under CloudFormation, there's some visualization for the stacks. So this compiles to CloudFormation. So anything that you can use with CloudFormation, you can visualize it that way too. So it's definitely possible. There's probably some open source projects too, but within the AWS console, they have a way where you can navigate. You can see, okay, with what resources were launched, how are they connected? Yeah. Yeah. Well. Oh, one more? Yep.
Recommended CNAPs, multi-cloud, and why?
Well, I will say my company, we resell CNAPs, and we resell multiple of them. So I do not want to give a vendor preference, but if you come talk to me after the talk and I can discuss. Okay.
Thank you. Today we're going to introduce two important and interesting security challenges in software development and how we can use static analysis tools like CoQL to identify and address these issues before they become bigger issues. So my name is Tong, and I am a software engineer at the Microsoft Security Code Analysis Platform team.
And my name is Asha. I'm on the same team as Tong.
So let's pause for a moment and imagine ourselves in year 2035. What is the life you expect? Flying cars, humanoid robots? Well, I don't know, but there's one thing for sure. Technologies will undoubtedly evolve at an even faster pace than we expect. However, there's one imminent challenge that we need to prepare for now. Q-Day. So the name sounds cute, but the concept is quite a bit scary. The Q stands, here stands for quantum. So everyone has heard of quantum before. It's not just some vague sci-fi or spiritual concept. It's real and it's coming. So Q-Day refers to the moment when quantum computers become so powerful enough to break the cryptographic systems that's protecting our cyber world today. Many experts believe that Q-Day could arrive as early as the next 10 years. In fact, the National Security Agency has set a 2035 deadline for adopting post-quantum cryptography PQC across all national security systems. So why quantum computers are so powerful? Well, traditional computers use bits, and these bits are binary, meaning that they can be either 0 or a 1. Think of flipping a coin. So in classical computing, you flip the coin, and it lands either heads or tails. One outcome, never both. Well, in a very unlikely scenario, the coin might land on its edge. And if that happens, you should probably go buy a lottery ticket. But even then, it's still neither heads nor tails. In quantum computing, however, flipping a coin is not a or logic relation, but rather a and relation. So imagine the coin spinning in the air, existing as both heads and tails simultaneously. This is a state called superposition, which gives quantum computers a massive advantage in processing speed because they can handle multiple possibilities at the same time. Now, the ability doesn't come easily. So to maintain a qubit superposition stability, quantum computers need incredibly controlled environments. So devices like dilution refrigerators can keep quantum computers at temperatures as low as 2 millikelvin. So it's colder than the deep space. It's the coldest place in the universe. So this together gives quantum computers the ability to crack encryption easily. So the most popular cryptography used in security communications nowadays is asymmetric encryption. It encodes and decodes messages using a pair of mathematically linked public key and private key. So imagine Bob wants to send a message to Alice. Unlike in symmetric encryption, where both Bob and Alice share the same key, in asymmetric encryption, we use a pair of public and private keys. So Bob will use Alice's public key to encrypt the message before sending it to her. So this encrypted ciphertext is sent to Alice over a public channel. When Alice receives it, she used her paired private key to decrypt the message. The important point here is that even if someone intercepts the ciphertext along the way, they cannot read it without having Alice's private key. Bob knows Alice's public key, which anyone can know, but only Alice has the corresponding private key, so not even Bob can decrypt the message. As long as the private key is kept confidential, the data exchange is secured. But is asymmetric encryption truly safe forever? I'm going to use RSA as an example to explain. It's a very common, fundamental, and widely used asymmetric crypto system. Let's first look at why it was considered secure, and then see why it is going to be in danger if Q-Day arrives. So RSA is an example of trapdoor function, which means that it's easy to compute in one direction, but extremely difficult to reverse. Imagine multiplying two prime numbers, for example, 53 and 61. It's easy to calculate the product even manually, which is 32, 33. But if I give you a large enough number and ask you to figure out which two prime numbers were multiplied to get this result, it will be extremely difficult. What you see here on this slide is the product of two large prime numbers. So factoring this 24 bits long number could take 1,000 years, even with the most powerful computers we have today. This is the backbone of how asymmetric encryption like RSA works. RSA relies on on relatively simple mathematical concepts, prime numbers, what we just talked about, and modular arithmetic. I'm not going to cover all the math here, like how the equation is derived, but it's pretty straightforward. So if you're interested, you can also probably deduce the formula on your own. What I want to highlight here are the two keys we just mentioned. So the public key consists of two components. The modulus n, which is the product of two large prime numbers, p and q, that are kept secret, and the public exponent e, which ensures efficient encryption. The private key, on the other hand, is represented by the value d. So in simple term, it's calculated in such a way that it undoes the encryption done by e. So the security of RSA relies on the difficulty of factoring the large number n to get the two prime numbers p and q. Without knowing p and q, finding d, which is the private key, from e, the public key, is computationally infeasible. So RSA is powerful and has been widely used to secure the world for many years. But how do quantum computers threaten this? And why is RSA no longer considered fully safe when Q-Day arrives? This is where Shor's algorithm comes in. I'm not a quantum expert, so again, I won't cover all the math and physics details behind Shor's algorithm, but I will try to explain it briefly. So Shor's algorithm was developed by the American mathematician Peter Shor in 1994. It is a quantum algorithm for finding the prime factors of an integer using quantum Fourier transform, QFT. The QFT is a key step where the algorithm finds the period or the pattern in numbers. Quantum computers then can use the characteristic of superposition we just talked about to explore many possibilities simultaneously. So they can find these periods or patterns really quick. Once the pattern is found, it's used to factor large numbers, which breaks the RSA entirely. This ability to factor a large number quickly is what makes Shor's algorithm such a threat to modern encryption systems. RSA encryption depends on the assumption that factoring large number is hard, but Shor's algorithm drastically reduced the time that's needed to factor them using a quantum computer. So then you may want to know what is the recommended key length for RSA in PQC practice. As you can tell already, RSA key length affects the levels of security. In this diagram, you can see that as the length of the RSA key increases, the security level also increases. N-bit security, for example, 80-bit security, means that the attacker would have to perform 2 to the nth, which is 2 to the 80th operations to break it. Therefore, obviously, longer keys will in general be safer. The recommended length, however, is a tricky question. The standards are changing fast, so I want to be cautious, and I'm not saying anything for sure here. Just to give you some insight, I'm showing you the CNSA guidelines. The CNSA, which is the Commercial National Security Algorithm Suite, is a set of cryptographic algorithms promoted by the National Security Agency. And in CNSA 1.0, which is the current standard, a minimum of 3072-bit RSA key is suggested. However, in the proposed future standard, CNSA 2.0, it removed RSA entirely and suggests that it should be deprecated at that time. I've linked some helpful resources at the end, so check it out if you want to know more about the latest updates. Shor's algorithm presents a serious challenge to not only RSA encryption, but also other encryption methods. I'm quoting Arthur Herman, who is the director of the Quantum Aliens Initiative, that Q-Day is likely to come sooner than even quantum scientists can predict. And the time to get ready to protect our vulnerable data and networks is now. We need to prepare for this quantum-safe future by considering post-quantum cryptography practices that can resist quantum threats. One of the key preparation methods we want to introduce here is through static code analysis. The security standards are changing fast. We now have stricter rules for protecting data, but a lot of the older legacy code, or even the code we currently write daily, hasn't been updated to meet these new standards yet. It's very difficult to check manually where these vulnerabilities are in our source code. So static code analysis is important in software engineering. It is a method of analyzing computer programs without executing them. It examines the source code to identify potential bugs and security vulnerabilities early in the development process. Unlike dynamic analysis, which requires running the program, static analysis evaluates the code structure, syntax, and logic. In simpler terms, it's like proofreading code before it's even running, so that people can catch mistakes like outdated encryption methods, hard-coded credentials, or logic errors that could lead to bigger issues down the line, making software more secure and reliable. Let's take a look at some popular static analysis tools. You may have heard some of them before. For example, Roslyn and Prefast are very lightweight tools that's fast and doesn't require a build to run. But they only support C# and C++ respectively, and the scope is limited. Roslyn can only catch 3 flow steps, and Prefast is limited to the function level scope. I will talk more about what flow steps mean later and why it is important in static analysis. SamGrep is also lightweight, and it supports most coding languages and frameworks, including snippets. However, it only covers file-level scope and has limited semantics. Sonar Cloud offers great multi-language support and CI/CD integration. It's cloud-based, so it's easy to set up and integrate with various pipelines like GitHub or Azure. However, Sonar Cloud is a paid service, and it's not that powerful on deeper security analysis. CodeQL is a free semantic code analysis engine. It's acquired and now maintained by GitHub. So Asha and I are not on the product team, but we use and maintain CodeQL a lot in our work for static analysis. CodeQL supports full and thorough semantic analysis and can trace data flow across the global scope. So it's great for identifying complex vulnerabilities like SQL injection, cross-site scripting, or buffer overflow. The downside of it is that the learning curve is steep, so it can take some time before writing complex queries. It can also be slow on large code bases. If you compare these options, lightweight tools like Roslyn or SamGrep are great for quick surface-level checks. They can also be easier when writing custom queries compared to CodeQL. CodeQL, on the other hand, is an overall comprehensive option when it comes to deep security analysis. We will use CodeQL today to illustrate how it can help detect hidden security vulnerabilities, like the bad usage of a small RSA key in code, for example. As you may have guessed from the name, CodeQL combines both code and query language. At its core, it treats code as data. So we can write CodeQL queries, just like SQL queries, to analyze code for issues related to security, correctness, maintainability, and readability. This video shows how to create a CodeQL database in VS Code Terminal. CodeQL CLI extracts relational data from the source code to create a CodeQL database that has the information on how the code is structured. It represents functions, variables, and data flows as queryable data points. So code plus QL lets you query code as if it were data. In the next video, you can see how this database is used when writing CodeQL queries. Here's where the concept of AST, or abstract syntax tree, comes into play. The AST, shown in the red box here, is a tree-like representation of the source code. By treating the code this way, CodeQL allows the users to search their code at scale for complex semantics patterns. User can also customize the queries for specific patterns. Okay, so back to RSA encryption. I want to connect the dots here and show you a practical example of how CodeQL can detect the usage of RSA in the codebase. We have a simplified example here in Go language, where a RSA private key is generated using the standard crypto RSA package. The user specifies the key length as 1024, which was disallowed by the National Institute of Standards and Technology, NIST, 10 years ago, back in 2013. So it's definitely weak, and we should avoid from using 1024-bit keys, of course. So now, if the question is simply to detect any RSA usage, no matter where the key length, no matter how the key is used, we can write a super simple query in CodeQL to detect that. For example, in CodeQL for Go, The call to the wrapbox RSA.generate key is represented as a selector expression, and by having a query like this, any line of code that calls the RSA package will be flagged. You can also see here that CoQL queries follows the QL structure of having a from where select statement, where the select statement includes the final part alerts you want to create for the findings, such as this usage is bad and please use a stronger key length, blah, blah. Now, I know some of you might be thinking, why not just do a Control F to search for keywords like RSA? Why use CoQL? Well, one of the reasons is that the example on the previous slide was a super simple code that only has a few lines. Imagine code bases that have millions of lines of code with really complex imports, naming, and structures. Searching manually is a very time-consuming effort. A more important reason here is that CoQL can track the data flow from a source to a sink in the code. You have heard me talking about data flow several times, so here I'm going to explain it a bit. The actual thing we want to catch here is not the keyword like RSA itself, but how the data is flowed in a dangerous way. A data flow usually consists of a source and a sink. A source is where untrusted data enters the system, such as variables, user input, etc. For instance, in our RSA example, the source is a small key length 1024. The data flow ends in a sink, which is where this untrusted or weak data is used in a potentially harmful way. In this case, the small key length is used in the RSA.generate key function as a parameter for generating a private key, which should be flagged because we don't want to use this small key length. Asha is going to talk about tended tracking later, which is a more complex data flow scenario. But in this example, it's pretty straightforward that an integer source flows directly into a function called sink. We can then write a more specific and complex query that utilizes the data flow tracking feature in CoQL. In this more complex query, we define the source as any integer that's less than 3072 bits long. I chose 3072 because that's the CNSA 1.0 suggested length, but keep in mind that it's subject to change. We then define the sink as the second parameter in the RSA.generate key function call. So CoQL is then able to track the flow from the green box, which is the source, to the red box, which is the final sink of the source. The syntax might seem weird and not very intuitive. For example, you have 4 columns in the select statements instead of just 1, but don't be scared. That's just how CoQL is written for showing both the sink and the source in the final alerts. This is what you will get by running this query in VS Code. It will show you the bad source and the potential sinks of the source, and also the location info of these information in the file. You can see that the blue 1024 here is a clickable element. So clicking on it will take you directly to the line of code where the RSA key is defined, which is the source. This is also an illustration of why CoQL is powerful, because you can have the primitive values as an AST node so that you can trace down the entire data flow. For more information on how to start your first query, we have included a resource section with helpful links at the end of the presentation for you to refer to. So I've only scratched the surface on PQC today. My team at Microsoft and some folks from GitHub and Santander Bank have worked on an exciting project that used CoQL to analyze the security status of the top repos in GitHub to facilitate PQC adoption. You can learn more about this in the blog post linked here or by watching the Black Hat presentation recording about this project. Well, to conclude my part, I guess the takeaway here is that we need to start preparing for post-quantum cryptography, but don't be panicked. I don't want to deliver the wrong message regarding crypto, so I'm being super cautious. I know the NIST has proposed a pretty ambitious transition timeline before 2033, and that the final FIPS validated standards for the algorithms are out already. However, some of the work for how to adopt them, for example, combining traditional methods like RSA with new methods like module lattice-based mechanism, is still in draft form. While RSA is not broken yet, we have to assume a cryptographic relevant quantum computer may soon exist, and that we should take the appropriate steps to protect ourselves. In the interim, NIST suggests that CNSA 1.0 compliance, I showed previously, should continue to be required. So let's start by practicing static analysis to check for the weak crypto usage in our code. While PQC raises really big security questions, CoQL is also a great tool for detecting more immediate vulnerabilities, often seemingly trivial, yet very crucial ones. Next, I will hand it over to Asha, who will walk you through an example of another interesting topic, the leap year crisis, since this year, 2024, is leap year. She will also introduce other fascinating aspects of CoQL, such as chain tracking or MERVA, that will give you more abilities and flexibilities to write your own customized queries.
All right, so to continue on our presentation, I wanted to talk about a technical issue that's been affecting software systems worldwide, what's commonly referred to as the leap year bug. This may sound pretty small or obscure, but this bug has caused significant problems to systems ranging from personal devices to corporate servers. So what exactly is the leap year bug, and why does it matter? To understand the leap year bug, we should probably review the concept of a leap year. As you probably know, most years have 365 days. However, the actual time it takes for the Earth to orbit the sun is roughly 365.24 days, which is known as a tropical year. To account for this extra fraction of a day, we add one day, February 29th, every 4 years. But it's a bit more complex than that. A year is a leap year if it's divisible by 4, but not if it's divisible by 100, unless it's also divisible by 400. For example, the year 2000 was a leap year, but the year 1900 was not. Now, what does this have to do with bugs in software? Many systems and applications are designed to handle dates and times, but not all developers account for the rules of leap years correctly. When software is written without properly accounting for these, it can result in what we call the leap year bug. This bug occurs when systems fail to recognize February 29th, add or subtract days incorrectly, or mishandle dates around those leap years. The most famous case of a leap year bug occurred in 2000, the first leap year of the modern digital age. Some systems treated 2000 as a regular year because they followed the rule that said a year is not a leap year if it's divisible by 100. They completely forgot the exception that it could be because it's divisible by 400. This oversight caused applications to crash, others to display the wrong date, and others to completely malfunction. Issues arose in mainframe systems, financial software systems, and embedded systems like medical technology. For instance, some of the older mainframe systems and financial software systems incorrectly calculated dates, leading to erroneous billing cycles, miscalculated interest rates, and scheduling issues. Though the largest disruption occurred in February of 2000, there are major cases that occur every leap year. I've attached 4 examples of these disruptions here, but we'll be focusing on one of the largest disruptions in recent history. In 2012, Microsoft Azure's cloud platform experienced a leap year bug. Azure is one of the world's leading cloud services, and its outage had a global impact. The problem occurred because a portion of the Azure infrastructure didn't account for the extra day in the leap year. When the system tried to calculate certificates based on date and time, it failed, causing a massive service disruption. As a result, businesses relying on Azure for hosting, data storage, and other services faced unexpected downtime. The outage lasted for over 12 hours, leading to significant operational and financial losses for companies around the world. While that slide showed some of the major, well-known leap year bugs from the past few years, there are security concerns that arise from these all the time. Leap year bugs can cause systems to mishandle date-related data, leading to improper storage or deletion. Sensitive data being lost or leaked due to an incorrect date calculation can lead to breaches that expose confidential information to unauthorized parties. Software improperly allocating memory when handling dates in a leap year can lead to memory leaks, where resources are consumed but not released, degrading system performance and creating openings for attackers to exploit the system. Some security systems rely on time-based authentication tokens, the way that Azure did, and those expire after a certain period. Leap year bugs disrupt the handling of these timestamps, which might cause some users to experience authentication failures and other unauthorized users to gain access to systems. Overall, leap year bugs aren't just a nuisance. They pose serious risks to security, data, and operations. Properly addressing these vulnerabilities is essential to ensuring that digital infrastructure remains secure and reliable. So, how do we go about preventing these issues? For developers, the answer lies in testing and planning ahead. Modern software relies heavily on automated testing, and any system that handles time or scheduling should account for leap years. This might sound simple, but the sheer complexity of date calculations means that it's an extremely easy mistake for developers to be making. Over time, many date and time libraries have been improved to handle these cases, but bugs still slip through. Therefore, we recommend the use of static code analysis. As Tong mentioned, that's the process of examining source code without executing it to identify potential issues. Specifically, through CodeQL, teams can improve code quality, security, and maintainability before software is run. In this section, I'll be going over 2 of the most common leap year bugs that we had found, some examples of them, and work through an example of writing a CodeQL query to find all common versions of this flaw. As Tong mentioned, and this is just a full disclosure thing, Microsoft, which is our company, through GitHub, did acquire CodeQL a few years ago. We're not on their product team. We don't do anything in terms of sales or anything. We're just speaking to this because it's the tool that we use internally and is the static code analysis tool that we're most comfortable with. My aim in this part of the presentation is to talk about the capabilities that you would want in a tool and the things that many static analysis tools can do as well. Before we get too deep into it, we also should understand what an anti-pattern is. An anti-pattern is a common but counterproductive solution to a reoccurring problem in software design or development. It often seems like a good idea at first, but over time can lead to negative consequences like poor performance, increased complexity, or maintainability issues. Recognizing and avoiding anti-patterns is important for creating more efficient, scalable, and sustainable systems. Currently, the main usage of CodeQL is to find anti-patterns to flag. All of the queries that we write internally and the queries that are required by our company are based on anti-patterns that have been found by the public. For leap year, we had 9 anti-patterns that we were working to solve before February of 2024. These revolved around the addition of unsafe values, combination of date values that could be harmful, storage of values, and more. For this example, we're focusing on 2 of the existing leap year anti-patterns that are similar enough to kind of understand together. While there are other leap year anti-patterns we could have focused on, these are just the easiest to jump into and understand. Anti-pattern 2 typically occurs when a developer wants to add or subtract some number of years, typically 1, to a date, but does so using a multiple of 365 days. With the introduction of a leap year, these could cause those dates to be off by 1, leaving room for any of the security flaws that I was going over before. Adding 365 days to February 29th, 2024 leads to unknown behavior where the date could either normalize to March 1st, 2025 or back to February 28th, 2025. The leap year doesn't necessarily need to be involved though. Subtracting 365 days from July 1st, 2019 gives July 1st, 2018, but subtracting 365 days from July 1st, 2020 would give July 2nd, 2019, excluding the other July 1st. Anti-pattern 3 occurs in a similar manner when a developer wants to add or subtract some number of months, but does so using 28, 30, or 31 days. By not considering a leap year, they may be adding 28 days when in reality they mean to add 29. Similar examples, adding 28 days to February 1st, 2019 does give the correct date of March 1st, 2019, but adding 28 days to February 1st, 2020 gives February 29th, 2020, instead of the March 1st date that was realistically expected. This is the most common response. However, different packages in different date languages have different behaviors for overflow of days in a month. Some may throw an exception while others wrap to the next day, but since we don't always know the answer, that's why it is seen as an anti-pattern. Here are the 2 most basic examples of these anti-patterns in practice for JavaScript. For both, a new date object is created, and then a number of days is added as a constant using the setDate function. Each of these would be flagged by CodeQL for their use of 365 and 28, respectively. The correct solution in this case would be to use a proper datetime library rather than just doing simple constant addition like this. Now, for the actual writing of a CodeQL query, we'll be focusing on anti-pattern 2. Which, as said on the previous slide, looks at the addition and subtraction of 365 days. On the right is a sample file that shows some examples of the anti-pattern in practice. The first one shows the creation of the date, followed by an addition of 365 days to that date using the setDate function. The second one does the same thing, but does so putting 365 in a variable just to show how the data flow or taint tracking could work in this scenario. And the third adds 365 days to a new date object by creating the date object from a calculated timestamp. That one is specifically there to show why a simple Control F wouldn't work. Random other ways of creating the same problem can always come up, and using static code analysis is really helpful to just grab all of those. Based on these samples, we have 3 alerts we would like CodeQL to find. Does anyone have any ideas what lines they would be on, if you can read the line numbers from where you are? If you could guess and see it from where you're sitting, lines 3, 8, and 12 should be the ones that are alerted, with the entire statement with the addition being highlighted. Based on this, we can begin the process of creating a query. As Tong mentioned before, I wanted to be touching on taint tracking. This is something that is absolutely necessary for this query. Tong explained data flow before, how it traces the flow of information from one part of a code to another. CodeQL taint tracking, on the other hand, focuses on tracking the flow of potentially dangerous or untrusted data, known as taint, within a program. It identifies the sources of untrusted input and then follows that data to determine if it reaches vulnerable parts of the system without proper validation or sanitization. Taint tracking is different than normal data flow in that normal data flow libraries are used to analyze information flow in which data values are preserved at each step, while taint tracking uses it to analyze information flow where data values could have tainted a different variable. For example, if you're tracking an insecure object X and the statement y equals x plus 1 pops up, a normal data flow analysis will highlight the use of x but not y. However, since y is derived from x, it is influenced by that tainted information, and therefore it is also tainted. In this specific query example, we need to be using taint tracking since we're following the path of an addition or subtraction of a value to the use of it in a date function. CodeQL makes taint tracking extremely easy, so all we have to do is identify the sources of the taint and the sinks, and CodeQL will find the paths between them. So since we're looking for the sources and sinks, we're going to be starting with the sources. To find the sources, we need to find the specific pattern that leads to the problem. In this case, it's anything that involves the addition of 365 to another value. We look for this because this pattern doesn't necessarily mean it's the full problem we're looking for, but it's necessary for that full anti-pattern to be found. Highlighted on the screen are the 3 examples of this from the sample code we're looking at. And if you see, the actual date object plus 365 doesn't actually prove that there's a problem until it's actually used in this sink. It needs to flow into a sink that makes up the rest of the anti-pattern. In that case, it would be the use of the setDate or the newDate function and constructor, respectively, that end up flagging the code. These are the same highlighted portions as we showed earlier on lines 3, 8, and 12, because these are the final portions of the code that should be alerted. Now that we know that, it's finally time to actually start writing that query. So to start, we first have to do the imports. We import in JavaScript, as that's the language that is currently being scanned. Each language has slightly different styles of query authoring, so that's a necessary line. The following 2 imports are dataflow and dataflow pathgraph. Dataflow allows for use of the dataflow and taint tracking modules, and pathgraph enables path exploration and visualization of data flow through the code. Enabling pathgraph allows for the visualization from sources of taint to sink in an interactive manner. Finally, we import classify files to allow for the removal of auto-build and auto-generated files later on in the code. So now looking at the code, we can begin to build the parts necessary to find the sources. To start, each of these classes has the statement extends something. So in this case, it says class unsafe year arithmetic nums extends expression. CodeQL has built-in classes with methods that can be used. We usually end up extending the class that's most similar to the object we're trying to find. Resources that explain this more in depth are attached to the end of the presentation. First, we want to find all the places that there is a number 365. This is the first step in building the source, as there has to be addition involving the value 365. To do this, we create a CodeQL class that finds either the number 365 or 525,600,000, which is that timestamp value measured out. And then there's also the case that someone, when they're trying to figure out dates, does 365 times 2 or 365 times 3. Instead of just adding years, they just multiply out for the number of days. So the third statement is finding any multiplication that does that. And it's a little bit of a complex looking thing, but it basically says that given a multiplication expression, if one of the operands in that expression is the integer value 365, it counts. When we run an evaluation of this class, the 3 orange boxes that are highlighted on the left would be found. Using the unsafe year arithmetics nums class, we can find any of the addition or subtraction that may be happening in the code. The next class, arithmetic year ops, begins by finding an addition or subtraction sign like the plus or minus. Then it looks for 2 possible options. The first is the most basic option, where there is a addition or subtraction thing that's happening, and one of the operands of that is an unsafe year arithmetics number. The second case is that the unsafe year arithmetic number is stored in a variable. In that case, it looks for the addition or subtraction expression, finds that one of the operands is a variable, and then finds that that variable has one of those unsafe numbers stored in it. Using this arithmetic year ops class, we can find any of the possible sources of this sample code as seen with those blue highlighted boxes. And you can see how the orange kind of goes into that blue. Now that we have those sources figured out, we can move over to the sinks. The first sink possible is the setDate class. To find this using code QL, there's a simple class that can be made that looks for any callees that are specifically called setDate. Running this code QL class will find those 2 purple highlighted boxes. This one is a little bit more complicated, but still the exact same idea. In the case needed for this anti-pattern, the number 365 must be affecting the year value of that new date instantiation. However, when using a new date constructor, the year, month, or day can all be set. So our code needs to be able to specifically grab that year argument as a sink. To do this, we can make a class that has a characteristic statement that makes sure that it's a date, which we do with the get callee name equals date, and then have multiple other methods within it that can identify the year, month, or day arguments. Since each of those are always set at a very specific location, 0, 1, or 2 respectively, the code can look for the value at those specific arguments. Running this date instantiation core class finds the 3 pink boxes highlighting the new date, and then running get year arg specifically finds that red highlighted box. Are there any questions before we keep going on the source and the sink stuff?
So if you're trying to do the right thing, don't those constants show up in your code? Like you have all the control flow to check, like won't that catch the correct implementation?
So it can also catch the correct implementation, which is also always one of the problems of static code analysis. What we try to do is we typically look for those false positives, so that way we can specifically gear them out. In this case, the correct way of doing it would not be to use like a set date like that with an addition. It would be to use a set year function, which does exist in the same class. So that correct version of it that's found with the anti-pattern and in the anti-pattern explanations online aren't going to be flagged because we don't look for set date specifically. Or set year, sorry.
So good code remediation would be for all developers to add year 1 rather than add days 365.
Exactly.
Because add year in the operating system or the implementation would take care of year 100, year 400, leap year, everything.
Yep, most of the library packages that you can use for this stuff does actually already take care of that. The problem is usually when developers are doing it more manually because that's just the habit that we all have. All right, continuing on. Now that we've had those, we can add them to the taint tracking configuration. This module exists in code QL to use the taint tracking capability. So we start out by making the characteristic statement of year data flow that just explains what this module is doing. And then in this case, it says finds where 365 is used in a year addition or subtraction. Then we have to override the isSource and isSync statements. And each of the source and sync have to be written out. In this case, the source is arithmetic year ops, as we found out earlier. So line 70 says that if an arithmetic year ops object exists, it could be a source, so save it as a starting node. In this case, it's, once again, all of those purple boxes. The next 2 lines remove all of the library and auto-build files that typically come along with making a JavaScript project, so that way we don't get an influx of results that we can't control. Within the sync predicate, we know that it either has to be a set date object or a date instantiation core object. So what this is saying basically is that if a set date exists, that could be a sync, so just save it as an endpoint. Or if a date instantiation core object exists, once again could be a sync, so save it as an endpoint. Behind the scenes, when we run this, CodeQL will look for any paths between those starting nodes and those ending nodes. And if one exists, that means there is a path from a bad start to a bad finish. And we have possibly found an example of a true positive for the addition or subtraction of 365 days. Now that all of that is done, we can finally write the select statement, and that's the true part of a CodeQL query. It includes a from, where, and select statement. The from statement chooses the variables that will be used in the query. The where statement defines the bounds of what would be chosen, and the select statement is the output of the overall block of code. Here, we say that given a source and a sink, where there is a year data flow with a path from that source to that sink, we can select those values with a message explaining the problem. This is similar to an SQL select statement, though some of the syntax is just weird and it's something you end up having to get used to, and you look at the references a lot. While I'm not running this live, it's really similar to how Tong's example from earlier was run. The alerts that are found are underlined in yellow on the left side of the screen, and that's what the code shows. And then below the actual query statement is what the alerts look like in terms of when you run them, the messages that you get, with the same blue lines that if you click on them, they would bring you to the correct place in the code. Now, at this point, we have a properly flowing query that will summarize the anti-pattern shown. So this example only shows this working on a 20-line file. How do we actually use this in practice? We use multi-repository variant analysis. Also known as MIRVA, this is a powerful tool for examining code over different repositories. MIRVA ensures consistency and highlights the impact of changes on each of the code bases. Here, MIRVA allows for CodeQL to be run on up to 1,000 repositories on GitHub from VS Code at a time. Leap year queries are really any queries that find problems, can be tested on large amounts of data to find a majority of instances of a security flaw. As a consumer or an external person, if you would want to use a similar process with MIRVA, GitHub has a CodeQL database for every repository that has enabled code scanning. This means that your queries can be run on any of your own GitHub code bases, and you can make them yourself and run them personally. And with that, we've reached the end. CodeQL and really static analysis as a whole are very useful tools for security and finding bugs before major events occur. Having something like this that allows for large code-based scanning and finding every instance or nearly every instance of a problem that can then be sorted and fixed is a tool that shouldn't be taken lightly. We've attached extra resources that can connect you to more about PQC and CodeQL as a whole. Please let us know if you have any questions. We also really quickly wanted to thank our team back at Microsoft for their help in finalizing this talk and all of their suggestions along the way. And here are all those resources. Are there any questions?
So I got glasses, a little hard to see, so there's no back here, but is the two parts, so is the select statement, is that actually then where it's going to show back in the source code? Do those match up?
Yes.
So then, the follow-on to that is, when you have, like, what is any best practices, or what you guys have learned is, what do you target for your select statements? Is it like where I set 365? Is it where I need a set date? Is it where I've done the math on multiplying 365 by 2? Or can you show it in all of them?
So that's the nice thing with using like the taint tracking or the data flow things. It does show you every single step of that process and it would, unfortunately, it can't be run live because one of the problems with data flow and taint tracking and something that Tong brought up earlier, it is extremely slow. But when you were to run a data flow, it would actually highlight every single line that one of those happens on. So the way that this is showing up with those squigglies under the yearbad.getDate is that it highlights the argument of the final call. That is the problem. But with the data flow, it would show you where the 365 is, where the addition is, where the addition moves to throughout the process, and then finally where it ends up. Exactly. Mm-hmm.
Have folks considered tools like Graudit, G-R-A-U-D-I-T? You just kind of like look that up. Graudit, it's grep audit.
Mm-hmm.
It also does a very strong, I would say, a ranges above what Grodded goes. Because Grodded relies on grep rules.
Yes.
So you could grep and find 365, but then 365 could exist in hundreds of places.
Exactly.
The false positive rate would be very high. I think this is awesome.
Yeah. And then the other issue is like stuff like with timestamps or if they're using like bigger amounts of days. Those were always the problems that we had with it. But I actually have not thought about Grodded before, no. Yeah. Yes.
How close are we to Copilot being able to generate the code QL that want to learn code QL?
Honestly, I don't think, I will say it was not as hard to understand as it was to explain. But I don't actually know how close Copilot is. We, just Microsoft as a whole has been working more to get Copilot more integrated into things, but especially with security, it's always like a little bit of an iffier statement.
You have the biggest data set, right?
Mhm.
That's what you're using.
Yeah.
I guess a corollary to that question is, I think I heard you mention is that your code QL is different based on the language that you're parsing.
Mm-hmm.
And so is there effort, or even a roadmap to where code QL becomes more abstract? Where I look like when a date function is called on 365, and it's the same code QL regardless of whether it's JavaScript or C# or C++.
So that's actually more on the product side of things, which is the GitHub team, which we don't work with. But I believe there is an effort, as far as I know. But the bigger issue is more just like object-oriented code versus scripting languages have such different ways of writing languages that it's really hard for an objects, like an AST tree, to actually be able to like manipulate them the same way, which is why all of those languages end up being mixed up a little bit. Yes. To a what language? I don't believe it's easy. However, I have met people who have done it. Do you know the answer to that one? Like extending it to a different internal language. I was incorrect. It only supports those several big languages. Yep. Yep, so that's exactly what we do. Typically, the life cycle process of this is running it like this. So actually, the way that I was running it when I was creating this presentation was all locally on a sample test that I had made to find false positives, true positives, whatever. And then we run it in a little bit of an environment to see how many false positives we find when we run it on a larger amount of code. And it's just a cycle until we get the false positives down to like less than, I think, like 5%. Yeah.
So we do create like task images for each code we write to see like how many false positives.
Any other questions? Okay, thank you so much.
welcome everybody. Thank you for showing up for a later afternoon talk here, but this is What the Function, a deep dive into Azure Function App Security. We're going to be talking about the Azure Function App Service in the Azure Cloud. A couple of quick backgrounds here. I'm Carl Fossen, currently a VP of Research at NetSpy. I've been at the company for 13 years now, so I've seen lots of different things at the company and worn a lot of different hats. But during that time, I've been a pen tester, helped lead the cloud pen testing team, ended up co-authoring a book, Penetration Testing Azure for Ethical Hackers. I also created the toolkit Microburst for pen testing Azure environments. So done a little bit of cloud stuff over the last few years, but yeah, here's Thomas.
All right, thank you, Carl. I'm Thomas Elling. I'm a director at NetSpy, and I focus specifically on Azure Cloud and Google Cloud Security. And fun fact, I was also a technical editor on Carl's book, so also contributed to Microburst a little bit as well.
So before we get into our contributions to the research here, want to take a second to highlight all of these other names on here. Now I know that's probably really hard to see in the back, even up on those TVs over there, but all of the folks that we have on the list here have contributed in some way, shape, or form to the research that we're going to be talking about today. So if anybody's watching online, we'll have the slides out available with the links available. But definitely go check out the research of all of these other folks. We'll try to point out specific research points as we go through the presentation of, hey, this is Andy's work, or this is Rozier's work, or something like that. But a lot of the stuff that we'll be referencing comes from these blog posts here, along with some additional stuff that we've put together on our side. So quick outline here of what we're going to cover. We'll give everybody an introduction to app services and function apps, since not everybody here may have experience with Azure. We'll give you an overview of how those things work. We'll explain how the storage accounts work to support function apps and explain some key decryption that Thomas will highlight here. And we also have the VFS file APIs and some vulnerabilities we identified around those. To start things off, we're going to explain what app services are. So for those that are not familiar with Azure, Azure being the cloud platform from Microsoft, they have application hosting as a service through the app services service. So you have an app service resource that gives you an azurewebsites.net domain name, and you can host a website there. If you want a really cheap and or free way to host a website, this is it. Like, sign up for an Azure account, create an app service plan on the free tier. You get a free web server that can host whatever you want, and you've got a domain name on azurewebsites.net. You can put custom domains on there. I find it one of the easiest ways to host a web server out on the internet. Really big fan of it. Only alternative to that would be like storage accounts in Azure. If you just need HTML, that's super cheap. That's even more free than the free tier on the app services here. But yeah, really easy container-based way to host web applications up in the Azure cloud. They are somewhat vulnerable to subdomain takeover. So if you have a subdomain for a parent domain, whatever, we'll use netspy.com here. If we had BSidesPDX.netspy.com pointing to an Azure App Services app, and then we just deleted the resource and kind of forgot about the subdomain redirect, somebody else could create that same app services name, call it BSidesPDX.azurewebsites.net, and take over that subdomain redirect so that they could take over that subdomain from NetSpy. This is kind of fixed. We've seen it work in some situations. I actually just saw this exact scenario work a week ago, where somebody noted that there was a subdomain for one of our clients that was pointing to an expired resource for azurewebsites.net. We fired up one of those app services apps in our own tenant and took over that subdomain, got a full SSL cert and everything, and had a client domain at our disposal. So definitely keep an eye out for that if you're looking at subdomain takeover opportunities. The app services resource type also supports integrated authentication providers, so things like Entra ID authentication, where your Microsoft account, you authenticate to Microsoft, they authenticate you to the web application here, or other OAuth providers, your Google, Apple, Facebook, whatever. This authentication support actually resulted in a very interesting vulnerability that Wiz reported a year and a half ago, almost 2 years ago now, called the Bing Bang vulnerability. They basically took over the search results for Bing through an authentication provider on one of these app services apps. Basically, their auth provider said, yeah, anybody with a Microsoft account can log in here. And Wiz found that login, logged into the application, and took over all of the Bing search results. So you could take over front page results. Really interesting thing. Definitely go give that a read and look that up. So with app services, you have a couple of different ways to manage the app services applications. You have a console, which is the top screenshot here, that's built directly into the portal. With the right permissions, you can just hop into that and execute commands in the container. Alternatively, if you have the right credentials or the right roles in Azure, you have the Kudu interface or the SCM interface, which allows the exact same functionality, but it also allows for things like file upload, file download. It's hosted on the scm.azurewebsites.net subdomain. So that's why we call it the SCM interface sometimes, or refer to it that way. Both of those are handy ways to get command execution in the containers. So if you're ever pen testing an app services application, really handy way to get things like environmental variables out of there if you have the right permissions to access that. Finally here, it supports managed identities. So managed identities are a concept within Azure where you have a resource and it wants to be seen as a user in Entra ID. A managed identity would basically be the web server saying, hey, I'm this web server, go ahead and give me access to these specific Azure resources. You get tokens for that. Those tokens can be used elsewhere to then authenticate to Azure and act like the web server somewhere else. So if you wanted to read a key vault somewhere else, you get the token, you go somewhere else, use the token to go read the key vault. So handy for an attacker, but also as somebody building applications. Question?
Humans can masquerade as services. That's the one.
What is that?
Humans masquerading as services.
Yeah, so the question about it was humans masquerading as services. Yeah, you can take the token and pretend to be the service, basically, outside of there, with little logging around it. So it's kind of hard to track down. And all of app services is technically inclusive of function apps. Function apps are really just the API component of a web application built on app services. So if you just want to limit things down to, I just want to host an API that takes JSON input, that's a function app. Really, really easy to use to spin up your own APIs. I use function apps for all sorts of stuff. If you just need a really lightweight API to spin up, function apps is what you want to go for. The functions themselves underneath the function apps are stored under the API directory. So if we created this HTTP trigger 1 function, that's going to be under /API/HTTP trigger 1. And we can see here that we have the code editor directly in the browser here. That makes it really easy to edit your functions. Like I said, anytime I need to spin up a lightweight API, this is my go-to. I can edit it in the browser. It's facing out to the internet. Super easy to use. It does support both Windows and Linux-based containers for running your APIs. There's benefits to each of those, and we'll talk about some differences in those later on. And it also supports the console and Kudu interfaces, or the SCM interface, for alternative management of the containers. And like I said, the editing in the portal is really, really handy. If you just want to throw some PowerShell in a function to process JSON coming in, easiest way to set up an API. And this also supports managed identities as well. We often see them used to reach out to key vaults, get secrets from the key vault to bring into the function app for doing some kind of processing. For authenticating to the function apps, you can have just purely anonymous, wide open APIs available. That's just the anonymous setting for that. But you can also have individual function level keys that are associated with the function. You might want to put those in place to prevent some random person on the internet sending random garbage off to your APIs. It's a nice way to protect it, and it's just a good base level authentication authorization schema there. If you want to go another step further, kind of higher up at the function level, we have the resource level keys, including the master and default key. The master key has full control over the function app. It can do everything with Function App. You can overwrite files, you can take over the containers effectively. That master key is very sensitive. You have to be very careful with that because you can do all sorts of stuff with it. The default key at the resource level is also sensitive because it allows you to make calls to any API functions underneath the Function App. So instead of just being able to call HTTP trigger 1, you can call any of the other APIs as well with that resource level default key. So technically like 3 different keys that you can think about with that, and support for anonymous as well. Likewise, this does support that integrated authentication. So if somebody with a Microsoft account wanted to call those APIs, you can still do that same integrated auth to call those APIs as well. And the service itself is actually supported by a storage account. Something that you'll see with a lot of different Azure resources is Microsoft likes to build on Azure. So you have function apps that are supported by storage accounts that run on containers that probably run in AKS. I don't know. Maybe there's some other container service that's orchestrating that. I don't really know. But the important part here that we're going to highlight is that storage accounts support function apps.
All right. So that brings us to account key decryption. So storage accounts are going to play a really important part of this. So per Microsoft documentation, and if you've ever played with function apps before, function apps require storage accounts to some degree, right? So depending on your runtime stack, depending on your operating system, depending on your deployment model, you may use containers, so blob storage, or you could be using SMB file shares. And depending on what you're using, one or many of those are going to be used within that dedicated storage account that gets spun up for your function app, right? So in terms of what's actually in, the storage accounts, your container files or your blob storage, that's where all of your web jobs data is going to be. So this is really important metadata for the function app to actually work, right? So you can see in the screenshot over here, we have Azure Web Jobs hosts, Azure Web Jobs secrets. Those containers are going to be really important as we kind of move forward and start talking about key decryption, because that's where your application and function keys are going to live. So that those master keys, the system level keys, the default kind of function level keys, all of those are going to be encrypted in a host.json file, and that lives in the container files. In terms of your file share files, that's where your application code, and again, your log files, is going to live depending on your deployment model. So if we're using just, an ASP.NET or a PowerShell core or a Python, function app, that's where you're going to see your files, in your data directories, your site www root directories, and things like that. And your file share files, those are going to be used by default in your consumption and premium plans. And all of these configurations that we're talking about are going to be default configurations. You can configure to actually save account keys outside of storage accounts. And likewise, for your application code, you won't always need to have your application code in SMB file shares. But in default configs, this is what you're going to see. And then in terms of queues and tables, you're really only going to see these with certain trigger types, but we're really just going to focus on HTTP triggers for the sake of this discussion. And that finally brings us to our key decryption overview, right? So like we said before, your function app keys are going to be stored in kind of container blob storage in an encrypted format, host.json, right? Access keys, as long as you have access to that host.json file, they can be decrypted within the function app container itself and offline, which is pretty significant, right? This works with Windows and Linux on pretty much any runtime stack that we've tested. And decryption requires basically 2 things. Your first thing is access to the encryption key that's going to be stored in an environment variable in the actual function app container. So you need some sort of access to the container itself to retrieve that key, right? And then, secondly, you're going to need to actually have the encrypted key material from host.json. So you need read access to the containers and the files there. Write access is what you're going to need to the actual SMB file shares, which we'll jump into in a bit later. We did report this to MSRC, and this was confirmed to be expected and documented behavior. So in terms of permissions, right, the key takeaway here, and basically all of these slides that we're going to be talking about afterwards here is that these are permissions only for the dedicated storage account that's backing these function apps, right? You need 0 permissions whatsoever to the function app or app services itself to perform these exploits, which is pretty crazy, right? Because when we're talking about these managed services like function apps and things like that, many people don't think about all of the backing services that are actually available in your Azure environment that you then have to worry about, right? So now your security threat model is not only these managed services, but all of these other sub-services that are being used by Azure as a part of that threat model and that security model that you're building, right? So kind of like a cross-service privilege escalation. So in terms of your read access to your containers, you need to be able to read that Azure Web Job Secrets container, list those files, and specifically access the encrypted content in host.json. Remember, these are data plane operations that we're talking about. Management plane operations are not going to be enough here. So you need to be able to read those files themselves. And then you're going to need to have write access to file shares. And this is going to be used to actually create new functions, upload your exploit code, right? And again, a data plane operation. So the way that you can actually get access, read and write access, there's a couple of ways. So in terms of RBAC roles and permissions, storage account contributor is going to get you both of those things. It'll get you read, it'll get you that write access. And the way that it does that is via storage accounts list keys action. So if you're not familiar with this permission, basically what it allows you to do is to actually list and use the shared access keys for a storage account, right? And that doesn't explicitly get you data plane operation permissions, but the shared access key does allow you to do all of those things. It's like your administrative level key. So you're going to want to look out for custom roles that has list keys action or specific data plane read and write operations. We kind of talked about storage key access, and that's that list keys action, but don't forget about SAS tokens as well. SAS tokens can be highly over-permissioned sometimes, so make sure to always double check your permissions in your SAS tokens that you get access to. All right, so we've talked about storage accounts, we've talked about what permissions you need. Now we're actually going to start attacking these storage accounts themselves to affect the function apps, right? So what we're going to do here is we're going to create a completely new function without function level access or function app access by uploading data, uploading files to our dedicated storage accounts, right? So Roger Diekman has some really cool research on this where he attacks these storage accounts in a somewhat similar way. But what he's doing and what he's found is that you can actually backdoor a lot of existing functions just by modifying the file shares and the file share code to get access. We're not going to talk about that so much, but I do recommend you go and read his research there. Very cool stuff. So what we're going to do, instead of backdooring things, is we're going to create a new function. So if you look inside your SMB file share, in the screenshot over here, we're going to go to site www.root, and then we're going to create a new directory. We'll just call it new function or something like that, right? And within this directory, we're going to create a PS core or PowerShell function app, HTTP trigger. So we're going to upload run.ps1, which is going to contain all of our decryption code and things like that. Function.json, which is required by, I think, almost every function type. And that's going to define your authentication level. So let's see, right there, if you can see that. And in this screenshot, it's set to anonymous. And then we have type HTTP trigger, and then that also defines a few other more important things, such as the methods that are allowed and things like that. And again, what you're going to have to upload is going to be dependent on your runtime stack and programming language. So once you upload all of this stuff, create the new directories, put your code up there, you're just going to wait for that new function to populate. Your mileage may vary here, but we found that it takes maybe 5 to 10 minutes. Unless there is some sort of state-changing operation that actually resets the function app, then it will be almost synced pretty quickly. All right, so we talked about a bunch of stuff to kind of get us to the actual decryption. So the way that this decryption works on the back end is basically ASP.NET Core Data Protection. That is kind of the back end and the kind of core areas where all of this stuff happens. And we're not going to dig into this too deep because this is a very complex area. But what you need to know for the purposes of this is that Azure, and specifically App Services and Function Apps, has a specific library that it's built upon ASP.NET Core Data Protection called Azure Web Data Protection. And you can see some examples of code there where it's using the specific function secrets kind of protector to do these operations, right? And this library is in fact actually used within the function app container itself. So if you go and look on GitHub, this is all open source. You can see where this code is actually being used here, and you can see the actual specific Azure Web Data Protection Library. You can see that on GitHub right there. So you can take a look at that link. And funny enough, there was an MSDN forums post, and you can tell this is really old because we've got links stuck in there, where somebody was actually trying to do this many, many years ago. This code no longer works right now, so don't try it because function apps have changed. But the core concepts that this person was trying to achieve still hold true. So remember a few slides ago, we talked about how you could decrypt these access keys within the function app containers themselves and offline. This is how you're going to do it within the function container itself. So we're going to take that Azure Web Data Protection Library, put that into our actual run.ps1 code, right? And then at that point, we're going to take our encrypted application or function keys, whatever you're trying to decrypt from host.json, whether that be the master key, system key, whatever you want. And then you're going to put that and hard code that into your your code that you're pushing up there. You're going to add that new function folder, push those code files to that folder, and then basically, at this point, you can just wait for those decryption keys to come back to you. Decryption will happen within the function container itself because it has access to the environment variables. There's nothing stopping that code from getting access to those environment variables at that point. And then at this point, once you have everything decrypted, you can send that decrypted key off to your Burp collaborator server, to another listening web server, or just have it output directly within the HTTP response, right? So you can do this via your HTTP triggers, or if you want to use a timer trigger or something like that. The type of trigger doesn't matter too much here. And then, this is an example of where we are actually able to get it to run, and we have our master key stuck in Burp collaborator there. But what if we wanted to do this completely offline? We don't want to actually run it within the function app container itself, right? So the process is actually pretty much the same, but instead of our code doing all the decryption in the container, we just want to return the encryption keys to us, right? So if you go and look at that GitHub directory or that GitHub repository, there's going to be two environment variables where the encryption keys are going to be stored. And again, depending on your OS and your runtime, you're usually going to have to look at Azure Web Encryption Key or Machine Key Decryption Key. Those are where those are going to be stored, right? And you can kind of see that in one of these definition files up from on GitHub. Then you basically take that GitHub repository for the Azure Web Data Protection Library, fire up your Visual Studio, get everything running, and there's an actual test case that I use to get this spun up really quickly, data protection provider tests.cs. You basically replace all of the information and hard code it in this code right here. So we have just like our encrypted data, we have everything there and where we're creating our function secrets protector. And then we can basically do that all offline, not on Azure, not on the function app itself. And then you can write your unprotected or decrypted results to a file. And that's how you would get that to run there. So we'll include some examples here, in this tool, but
I can explain the tool here. So to automate all of this, because we don't want to have to do this by hand every single time, we wrote a toolkit called Funko Pop that will allow you to select a subscription. It utilizes the AZ PowerShell modules to list out the available storage accounts. So effectively, you're going to scan for storage accounts that might be vulnerable to function app takeover. And it uses those AZ PowerShell modules to look at the storage accounts, look at the files within them. You're going to need read and write access to those. So scan with somebody with, say, contributor on the storage accounts or storage account contributor, something with the right permissions to read and write on those storage accounts. And then it will populate the list of storage accounts that you might want to attack. When it does that, it'll actually show you the name of the function app that you're trying to attack. Gives you a nice little out grid view that you can select the specific function app you want to attack. And what it does at that point, it'll actually identify what operating system and what runtime it's utilizing. So it tries to figure out, okay, is it a Linux container or Windows? Because there's a couple of different code branches we got to follow that way. And then depending on the type of runtime, be it PowerShell, Java, Node, whatever, we got a whole table on the next slide here, it'll choose different kind of payloads for that specific runtime that we're utilizing. So you pick the storage account that you want to attack and the specific function, and it will upload the malicious code, which will then return back the decryption key along with any managed identity tokens if those are available. So that's kind of handy. And it'll clean up all of the code after everything's done. It helps if we just give you a demo of this, because this will show a little bit easier here. I think if you just click forward, it'll play. Okay, so we can see that we are SA contributor here, and we see that we have access to a couple of storage accounts. If we go to the function apps, we don't see any function apps. We don't have any access to any function apps. So as the storage account contributor, we can go ahead and browse and see, yep, we have storage account contributor here on the subscription. So we have access to all of these different storage accounts, some of which have function apps stored in them. And we run our code. So invoke AZ function app takeover. And we're doing device code auth here to authenticate first, which device code auth is fun for phishing and probably a whole nother talk to talk about. But we're going to run the AZ function app takeover, and it's going to ask us which subscription we want to select. We're going to go against our research subscription here, and we're taking a look at all of the storage accounts. So it found, 5 different function apps within that one, and we're going to pick, we'll go Linux PowerShell. So we've selected our storage account and function to attack. It's figuring out, okay, it's PowerShell, and I believe that it's Linux. It's creating the new function new folder within the function, executing it, and we got back our encryption key, the encrypted master key from the host.json. We got a management token, vault token, and graph token as well. So to explain this a little bit, Thomas already talked about the encryption key and the encryption master key here, or encrypted master here. And we're going to put those into the Funko Pop app, which is part of the toolkit. You can spin that up in your own function app here, and that covers the decryption for you. And hey, we decrypted it. But the management, key vault, and graph tokens, those are managed identity tokens scoped to those 3 different scopes. So management, graph, and vault, which would allow you to access those different services. And here we're just validating with another user that we got the correct master key out of that. So I know there was a whole lot of stuff happening all at once. One thing that I was going to highlight here is that when we create these, what we're doing is we're creating basically a folder that's named after a GUID, so nobody's going to brute force the name of the folder. And on top of that, we actually write our own host.json file to the container, and we actually set our own key to use to call that. So we set this completely random key to call the function, so nobody else is going to get access to this function that we're maliciously uploading here. So it's a safe way to run an exploit against this, I guess, kind of, I don't know. But one thing that I don't know if you touched on, did you touch about the encrypted true? Okay, can we bounce back? Like, here, I got it. So, is it here? Yeah, I don't know how clear it is, but in the bottom right-hand corner here on the host.json, you see encrypted true and the value up here. One of the other blogs that we have linked here, they figured out that you could just set the encrypted to false and set the value of the function app key to whatever you want. So if you have storage account access to the function app storage account, you can just set it to false and just set the key to whatever you want, and then you have full master key access at that point, doing basically the same thing we're doing. So we go a little bit more involved because we don't want to do major state change and like break existing function app keys that are there, but you know, it's handy. Okay, so last little bit about the tool here. We do support decryption of keys and managed ID token generation for everything but Java. So if anybody's a Java programmer and wants to write a payload for us to put into Funko Pop, just let us know and check out the repo. Neither of us really care to write the Java to do this, so we don't see that many Java function apps either. Like, we see all the other ones, but that's the one runtime we haven't tackled yet. So there you go. And we kind of talked about this as we were talking about the keys or the tokens that were returned. Now that we have these keys and tokens, what do we do? Well, we can use those tokens to query things like the management REST APIs, Vault APIs, Graph to dump out resources, get access to key vaults, potentially read things from Enter ID, anything like that, or from Graph. And with function app keys, we can use those to backdoor existing code, keep access to a function app. If we want to persist access to the function app, those keys don't get rolled that frequently, or it's pretty rare for us to see that to happen. So this gives you persistent access there. Or if you just want to use the functions, maybe it's a sensitive API that you're trying to call and it requires that function app key. You now have the key, you can now call the function. You already have access to the source code. Maybe that's a way that you get access to sensitive data that's in the function app. All right, so next up we're going to talk about part of function apps, but it's kind of a left turn from everything we were talking about with storage accounts. File access to the files that we were just looking at in the storage account can actually be done through the Azure portal. And up until about a year ago, reader roles all through any other higher privilege roles could read all of the files associated with a function app. So this includes base level kind of container files that we see up at the top. These are things like requirements.psd1 here, so PowerShell requirements, those kind of things. There's a root level host.json. We did oftentimes find sensitive data in those files as that reader role, but that wasn't enough for Microsoft to be like, hey, we got to restrict that. Readers shouldn't read that. Likewise with the function app code itself, which is kind of weird because reader can read code for things like automation accounts directly out of the automation account. But now you can't read the code anymore as reader role for function apps. So you can't see what the function's actually doing anymore. Probably a good thing. I don't know if readers really need to see that, but it's annoying. We often get reader level role when we start doing Azure assessments, and we're curious to see what's in that function app code. So yeah, anyways, point is from the portal, this is what it looks like. You can see there's file browsers at kind of both levels, at the function level and the function app level. And like I said, disabled for the reader role, but still definitely available for contributor and above. And the APIs that are used to pull those files into that web interface is what we call the VFS API. This is what that URL looks like for the API in the back end. You don't really have to worry about like sub ID or resource group, those kind of things. The important thing is that the VFS/. So basically we're saying for the specific function app, we want to use this VFS API. And you see the double slash there, that's the root directory, and the question mark relative path equals 1. That just sets the relative path saying, hey, just look here in the function app, ignore everything else. That's the relative path that we want to use, it's just starting the function app. Well, we can modify that. You can actually change that to 0 to show the root file system, and it drops you to the root slash there, just by changing the 1 to a 0 in the URL. And with that, for kind of every request that you make against this VFS API here, I know the text is pretty small here, but here we're going against ASP.NET, data protection keys, et cetera, et cetera. If you just do it at the slash for each of the directories, it does a directory listing for you, so you can just browse all the files and go after those. Again, this does require contributor level access. However, readers used to have access to this API, so they could potentially read all of these files. And for Windows containers, this kind of just resulted in access to the data protection keys. So the keys that we were using to decrypt for the Windows side of things, if you had read access on that host.json, you could then get access to the key here and decrypt those. Reader shouldn't be able to read that host.json, so not really a permission boundary issue here, just more of a, yeah, they shouldn't have access to that key. That was the initial thing that we found. When trying to replicate this vulnerability for a coworker here at NetSpy, I tried it against a Linux container, not realizing it was a Linux container. I thought I was replicating it for the Windows thing, and realized that, oh, you can actually just access the root of the Linux container and so much more. So for Linux containers, they have the proc file system, and for those that are not familiar with it, proc is basically your processes that are running. You can get a lot of different information about that. So we can see here like proc /proc/ 59 here on the top one, and that's for process ID 59. So if you go /environ for environmental variables, that returns the environmental variables. So we can basically script this or use some kind of intercepting proxy, something like that, and iterate through all of the available process IDs, get all of their environmental variables, which include sensitive data like the encryption key. On top of that, they have this thing called the container start context SAS URI, which is a SAS tokened URL for a storage account, lives off in Microsoft land, that lives for a certain amount of time, that contains a configuration for how that function app container is supposed to start up. So it contains some sensitive information here. We'll look at that in a minute. But we now have access to the encryption key to decrypt that SAS URI. And if we go next page here. So with the encryption key and the data from that SAS URI, we can see in the bottom right here, we see encrypted context. We grab that encrypted data, we take the key and the IV is being stored in the encrypted context here, throw it into something like CyberChef here and do an AES decrypt, because we have all the components to decrypt it with AES. And now we have access to the storage account connection string, which is the key to the storage account. So if you only had access to the reader level role here, you'd now have storage account keys to get into storage accounts. On top of that, it exposes the master secret as well as any function level secrets in this configuration. If there's any integrated authentication providers like Enter ID that exposed any of those secrets, all of those things are still available. The next thing is not. What also was returned in this decrypted configuration was an MSI specialization payload. And this is kind of short for the managed identity configuration. So if you had any managed identities associated with the function app, the certificates for them were included in clear text here in that configuration that you have decrypted. And that would include the PFX files in base64 format for the managed identity. And managed identities are never supposed to authenticate off of the resource that they're on. That's just part of how managed identities work in Microsoft Azure. That's supposed to be that resource. That resource is only supposed to authenticate as itself from itself. And with access to these certificates, we can then authenticate as the managed identity somewhere else. And this applies for both system-assigned managed identities as well as user-assigned managed identities. They're two kind of different concepts. System-assigned are tied to that specific resource. User-assigned are a subscription-level resource that can be shared against multiple different things. Either way, you as a user should never have access to those PFX files, which were being returned here. So what this did is this gave us an escalation from the reader role all the way up to getting full control over the function app, along with getting certificates to act as the managed identity outside of the resource. So pretty significant escalation up here. Along with that, when you authenticate with those PFX files off of the resource, Microsoft never expects you to authenticate as that managed identity off of the resource. So the logging just looks like you authenticated from the resource. They don't capture any external IPs, anything like that. So very limited logging on that kind of thing. But yeah, like I said, this completely breaks the model for how managed identities are supposed to work. And what do we got? Okay. So from a remediation perspective here, Microsoft is now encrypting the managed identity certificates. They did not necessarily fix the APIs. So as a contributor, like they fixed the reader level, like reading of the VFS APIs, but as a contributor on a Linux container, you can still get all of the decryption working and get that SAS context decryption working, but you get access to stuff you already have. So things like the function app keys, well, that is logged in the activity log when you take the action of listing the keys. This doesn't do that. So this is a potential kind of bypass or kind of sneakier way to get to the function app keys, but we also have the sneakier way of doing it by going through storage accounts as well. So we have a couple of different options for getting the function app keys. But yeah, as a contributor, you can still follow the same exploit. It's still pretty viable. Shouldn't really trigger any of those normal detections you might build up on that. But if you do have access to a function app, definitely take a look at environmental variables. There's some fun stuff that's there. Next.
All right. And that brings us to the end here. And we have just this basically a recommendation slide, of how you can kind of prevent some of these things, right? So least privilege and following that principle, just do it everywhere in Azure. Get used to doing it everywhere, right? Because even those things that you can't necessarily control that are kind of the shared responsibility or shared fate sort of thing, least privilege will help you a bit with that, right? So that's, thinking about things such as, limiting those roles, maybe not using owner if you don't absolutely need to, and then limiting the scope at which you actually grant those roles. So looking at resource groups rather than your kind of subscription level scopes. Specifically for function apps, you want to protect those storage accounts, right? So consider disabling access key authentication, using Entra ID authentication instead, disabling shared access key access altogether, and thus disabling SAS tokens if you don't need them. And obviously, don't store anything in clear text ever. That really helps. And then limiting permission on those function app identities such that if they are ever compromised, that blast radius does get a little bit smaller, right? And then when we're talking about specific function apps and storage accounts, kind of like you can really apply this to any managed service out there. It could be function apps, it could be Lambda, it could be, Google Cloud Composer or something like that. All of these kind of share that, usage of other cloud resources to support that managed service, right? So you got to include that in your threat model when you're thinking about that from a security standpoint. And for Azure specifically, use dedicated resource groups. Those specific resources that are dedicated to function apps, don't reuse those, right? It should only be used for function apps. And then finally with logging, make sure you have diagnostic logs enabled on both the function app and storage accounts so you can capture any of that activity that might be malicious, right? And we're talking about control plane and data plane logging for that. And right here in the corner, kind of small, we have Microsoft's recommendations for everything. So you can use key vaults to actually store some of these materials that we're talking about, such that even if you do get access to a storage account, you then need access to a key vault to go that next step further. So that's a good mitigation for this. VNet integration and making sure that it's not accessible from the public internet at all, also a very good mitigation if that's something you want to consider. And this is all of our MSRC disclosure timelines. So with all of these things, we do talk to Microsoft and work on coordinated disclosure, so you can see all of the details and kind of the timelines here for each of these issues that we talked about. And right before we leave here, we wanted to do a special thanks to all of these researchers that we had in that first slide. Roger's done a lot of great work. Andy Robbins, a lot of great work. Everybody up here has done some really great research in terms of managed identities, function apps, app services. So please go and take a look at their work as well. It's great, right? Very good stuff.
One thing I forgot to mention. Yes. So we do have links for the blog as well as the GitHub for Funko Pop here. Ronak and Chirag here, they actually had a blog post that talked about logic apps. So one other thing to think about with using the Funko Pop tool is logic apps that utilize the standard plan, which is kind of the fancier premium plan. Those are actually function apps. They're function apps under the hood, and you can actually target those. They have their own storage account associated with it. It gets spun up kind of in the side, and you don't really realize it when you set up that standard plan. Funko Pop and this whole attack thing can totally attack those logic apps as well, and we really frequently see managed identities tied to those function app or logic apps as well. So that might be a viable attack thing. Meant to mention that earlier, but saw their names up here and figured bring it up. So yeah, this is where you can find us if you have more questions or anything like that. Yeah, we'll be here, and thank you all for coming to the talk. I guess any immediate questions here before we wrap? Yep.
How do GCP and AWS do it better?
So the question was, how do GCP and AWS do it better? I'll let you cover the GCP side.
Sure, yeah. I mean, this is a really tough question because it goes back to the way that these cloud providers have kind of architected their managed models, right? So I've got a blog coming out actually relatively soon about something that I found in Google Cloud Composer. And the way that Cloud Composer works, if you're not familiar with Google Cloud or the Cloud Composer managed service, is it's basically Apache Airflow under the hood. And like Azure, like AWS, they actually use their GKE managed product and cloud storage buckets to actually back that service. So I think you're going to know where I'm going to be going with this. But basically, a lot of cloud providers do share these exact same things. The way that they approach and secure the managed services and those sub-services that they use are all going to be a little bit different, and they all make a little bit of different choices. But again, what it really comes down to is that shared responsibility model, is that they kind of put the responsibility on you to make sure you're securing all of these resources that are within your control, right? So I don't want to say somebody does it better than somebody else, but they all do it slightly differently. Yeah.
Any other questions? Yep. How did the tips apply to? Oh, so the question was around logic apps and how does that apply? Okay, so specifically for logic apps, if you're on that standard plan, that spins up a function app with a storage account in the back end. And all of those requests kind of get executed through that function app. It's through a Node.js container. That was actually part of the reason we pushed to get the payload updated for Node.js to work. It actually didn't work all that well before. But anyways, with the standard plan, you can do the exact same kind of attack where you're attacking the storage account. It just gets a little bit more complicated. You treat it like a regular function app versus treating it like a logic app. You could hypothetically go into the storage account, modify the logic app code, because there's, I don't remember the specific, do you remember? I think it's in JSON, I don't remember. I don't remember how that workbook actually works, but you can actually modify that and backdoor those as well. That was the blog post I was talking about with Ronak and Chirag. Yep, so the question was, do the tips for function apps apply to logic apps in that same way? Yep, 100%. As long as you're protecting that storage account that's backing the function app, that should help protect you. Yep.
It's a gold digger question.
Okay.
I'm a dedicated teenager who dives deep into Azure, reads your Azure pen testing book. Can I make a lot of money bug bounty hunting on HackerOne or Big.io?
Yeah, so the question was, is there monetary potential for hacking on some of this stuff? Yeah, Microsoft does offer bug bounties for stuff that's submitted through MSRC. You can go consult their whole bounty program thing, but they have a pretty generous program. Yeah, so Microsoft specifically partners with Integrity at the moment to process their stuff, but they take all of the input through MSRC's website. Yep. So if you want to hack on this stuff, definitely follow the Microsoft guidelines, check out the MSRC website. They give you a lot more recommendations around that stuff. Yes. Any other questions?
Thanks very much.
Yeah, thank you. All right, thanks again, everybody.
Hello, everybody. I hear a lull. I'm going to grab it. Let's start. Welcome to Beyond the Hacker Stereotype. Here's a little bit about myself. I won't go over the details. It's just to establish I do know a little bit about security. I have not been on the red team side. I've not done much hacking. I love going to DEF CON all the same. I always learn great stuff. Since this is a talk about careers, I'll just give you briefly a little sketch of mine because it wasn't entirely predictable. I started thinking I was going to be an English professor. That's like the first 10 years of my adult life. But I didn't. I ended up going into software development. And so that's another 20 years there in various software team tasks, after which I got tired of that and finally shifted into security. I call this slide Move Laterally and Escalate Privileges. Good, okay. I have, over the last couple of years in particular, through connections I have at Western Oregon University, at the local OWASP chapter, at some regional conferences and events, I've had the privilege of talking increasingly to people who are early in a cybersecurity career. Whatever their age is, they are starting off into that career. And it frustrates me a little bit, just irks me a little, because that they're not interested in what I do. I do blue team stuff. And they all come to the talks if we're having talks about how to do penetration testing. Then we have a lot of people attending. And that's perfectly fine. It's interesting work. It's hard to do. And it is a lot of fun. But there are other things in the world. So it seems to me like this is what they think the security world looks like. And this is what I think the security world looks like. So the point of this talk is really to cover two things. One is to list what some of those other hats you can wear are, and I'll describe them briefly and put up some facts about some of those roles. The other thing I'm going to do is, to get that data, I'm going to rely on a tool the federal government made that tries to categorize and describe in a transparent and consistent way the kinds of work that happen in the cybersecurity industry. So that gives my facts a little authority, a little systematic approach here. There's some data behind this. Just briefly, because I'm going to use these acronyms, the framework I'm going to rely on was created by a sub-branch of the Department of Homeland Security. It is the National Initiative for Cybersecurity Careers and Studies, NICCS. And they created this framework that I'm going to draw data from called the NICE framework, and that's an acronym too. But when you hear me say the NICE framework, that's what I mean. It's freely available on the web. I have the URL for it on the last slide. You can get to it and look it all yourself. It starts by, one of the core concepts is a work role, which is close to what a job is, and the difference is so small it doesn't matter much. It says there are 58 work roles in the cybersecurity industry, and I'm not sure they hit all of them. And it divides those 58, or categorizes those 58, groups them into 7 categories here. And since the categories themselves give you a sense of the breadth, I am going to spend a little time on this slide and say, first of all, they code everything. All the roles that are in oversight and governance begin OG and an ID number. It's like a little database. They have IDs for all these things. So the first section up there is about leadership, management, and advocacy within an organization to be sure that all the right security things are happening. What is our vision? What do we need? Have we hired the right people? That's the leadership side of it. The second row is design and development, and that's building and testing secure technology systems. So that's like building software and making a new product. I/O, implementation and operation, is running, maintaining, configuring, setting up, and using an information technology system. It's a typical IT department. The next one is identifying and analyzing risks to organizational infrastructure, information systems. Responding to attacks, this is a focus on digital evidence, so that fifth bar, investigation, that fifth row, gets invoked when something actually goes wrong, or preparing for the fact that something might go wrong. The last two shift more into stuff that more often happens in military or government organizations, but sometimes in very large companies like Microsoft too. or big consulting companies, gathering information from many sources, analyzing it, and producing information about threat actors' cyberspace intentions and capabilities. That is the penultimate row. And then finally is executing operations aimed at defending or projecting force through cyberspace. So that's like attacks and defense. So there's a range of things that are not by any means all hacking, although it includes hacking. So the core concept in this nice framework is a long list of work roles. I've said there are 58. 640 different knowledge areas that some of those work roles need to know. 556 skills that are spread out across those work areas, and 1,084 separate tasks that people do. So there's really a great deal of detailed information that somebody in the government with a lot of consulting with industry has put together to try and come up with a transparent way, a systematic way that we can like code work opportunities and be transparent about what's required, to describe it the same way in different organizations. One of the goals in this is to make it easier to bring people in. A lot of this tool is written by HR people for HR people solving their problems, not mine, and I found that that was sometimes a hindrance for answering the kinds of questions I wanted to get out of it. But they are thinking of us too, and there are ways you can use this to find things you're interested in. I began with a task imagining myself as a fresh college grad. I was an English major, so this is an English major example. And I probably picked not the best way to start with this framework, but I'm going to drag you through the steps that I went through because it does reveal something about how the framework works and what's in it. And then I'll go more quickly through the other ones. I opened up the spreadsheet that has all those hundreds of items in it with each one on a different tab, and I skimmed through the skills thing. I thought, I know what skills I have, or at least I think I do. I don't know what jobs I want. I want to start with the skills. Here are skills I have. What could I do with it is the question I wanted to answer. And I stared at read all these hundreds of skills for a while, and then I began to notice some that were interesting. And so I filtered the Excel spreadsheet to show me only the skills that have the word communication in them. And then I said, as an English major, there are two in particular that attract me. I'm interested in communicating complex concepts and doing it in writing. Those are things I could handle. So then my next question is, what job roles need those skills? So I go over to the other tab, the one with all the job roles, and there's a column of the skills listed by number, which isn't terribly friendly, but I remember the two numbers from the other page, and I've highlighted them where I found them here. And I sorted this, did the filtering in Excel spreadsheet and came up with 3 roles that need those 2 skills. And a lot of other skills too, I admit, but still, that's a good start. The first one attracted me, cybersecurity instructor. I wanted to be an English professor. I could have imagined myself as an instructor. This is a way in. And so then let's see, do I have this on the next slide? Yeah. That's the role I got interested in. So now for a while I'm going to think about what I can find in this framework about that cybersecurity instructor role. What other information is there? This is the UI they probably mean you to start with, not with the spreadsheet where I started. But it doesn't it doesn't let you browse by skills, which is how I go back into the spreadsheet. So now in the upper left, I know you can't see it. In a minute, I'll blow up part of this. But I have put cybersecurity instruction in the top left. There's a drop-down list. I found that role. And you can see it's pulled up information about that role. The next slide blows up the right-hand half of that picture to show just what some of those details, notice the details tab is highlighted. There are other tabs we'll go to in a minute. Some of the details offered about this role include functional job titles. This is what I look for on a job board. If I want to be a cybersecurity instructor, I don't look for cybersecurity instruction. That's just the framework's word for this role. These are the job titles where they might need someone who can do that role. There might be other job titles as well, but that's a good start. It gives me an idea for the kind of thing I might be looking for. I've switched down to the task statements, still looking at the same cyber instruction role. And now you can recognize probably these are tasks that were in that spreadsheet, but now it's showing them to me on a web page. And there are a lot of tasks, more than you see here, way more than you see here. But still, the top ones are interesting. It confirms I'm in the right place. This is a job about evaluating training programs, preparing and delivering briefings. Yeah, that's the kind of thing I thought would be here. Good, I'm in the right place. Another tab, common relationships. There are at the bottom on the right here 4 other roles from the workshop, from the framework. There are the codes and their names, and then a percentage on the right. That percentage is telling me how many of those tasks and skills and what are the other knowledge areas are shared between the role I picked and these other roles. So although I'm looking at cybersecurity instructor, that's 87% overlap with curriculum development. Well, that makes sense. But I might not have known there was a curriculum development role I could look for. And there's a significant amount of overlap, less than 80%, but still a significant amount with some other roles. So that might give me another area to look in and say, well, maybe I should be considering those too. Maybe I could find my way into one of those. The next another one of these tabs is capability indicators, and I'm going to go there next, except that when I click it, you get so much information it doesn't fit on a slide. So I have abstracted it off the website and just made kind of a sketch. There's way more information in there, but just to give you an idea what these capability indicators are like, it shows you a little bit about what you're expected to have in that job by the way of qualifications at different stages in your career. And since I'm imagining myself as a just graduated English major, I care about the first column. And the first column says an associate's or a bachelor's degree will get you in. Maybe I didn't need that bachelor's degree I just got. I could have got in with an associate's. This is a way to find that out. And that doesn't mean it's a hard and fast rule that you have to have one of those degrees, but by and large, in general, that's what's expected. That's useful information. It also says what areas I might look for training in. Maybe I can find a Coursera course, or maybe I already have a job and there's professional training there, or maybe I can find some books. Those would be good areas to focus on. And it tells me if I need credentials or certifications, if that's a common requirement for that job. Those are things I get asked, so I thought it was useful to see that they're here in the framework. Finally, and this is not part of the framework, I went on to LinkedIn to see if I could find an actual person who had a cybersecurity instruction role, because I wanted this to seem kind of concrete, like people in the real world actually do this. And here's somebody I found. And of course there were people with normal instructor roles, but I really liked his role. It sounded really interesting, so that's why I picked it. His role, if you can't read it, is Engagement Coordinator and Speaker at Microsoft's Cybercrime Center. That sounded like fun. He doesn't probably have to be the person who does all the technology stuff. He just has to understand it well enough to explain it to different kinds of audiences, probably with different degrees of technology familiarity, and make it sound interesting and exciting and important to them. I'd like that job. Even now, that sounds like fun to me. So anyway, I've finished there. We got to one role. There is one role, one hat other than hacker that you could look for. And I'm not going to drag you through all the framework steps and all the others, but I'm going to go more quickly through some of the other things you could find in this framework. So first role I'll take, or second role I'll take, cybersecurity legal advice. And here are the tasks, the skills, and the knowledge that the framework says you need if you want to consider this as your work role. This is a work role you might like if you like the idea of being the expert who guides the company through legal and regulatory issues related to cybersecurity. Again, this is not someone who programs typically. They may have written a few scripts somewhere. I mean, part of my message is there's a variety of roles that take a variety of qualifications, and it isn't all about being a deep hacker in order to provide deeply needed services. There are some job titles associated with the legal advice role. And here is a person who actually has that role. And again, not someone I know. I don't even know exactly for sure what Molly does, but I liked her. I picked her out in particular because she's not the contract lawyer for a corporation, which is kind of what I expected most of the lawyers to be. And I worked with them, and they do important stuff. I depend on them a lot. But she is a lobbyist. She works for EFF, the Electronic Freedom Foundation, of which I am a proud member. And she is working to influence public policy, which needs legal input and advice for regulatory decisions. So that's another angle you can go there. Definitely public sector people with legal advice. And here is another thing you can find for not all the jobs of this kind of in the framework, but this did come from the framework. It's a screenshot. It gives you an idea of the median salary, I think, for starting positions in this role, not for senior positions. I know senior lawyers make way more than that. But still, you want to know what might you be aiming for if you start down this road. You might start somewhere around there. And it confirms that, yes, indeed, you do need a law degree to consider this. All right. Here is a third role, knowledge management as a role. There are the tasks, skills, and knowledge areas needed to work in knowledge management. This is a role to consider if you like the idea of organizing information, ensuring teams have the right data at their fingertips, and making an organization better by improving how knowledge is shared. Imagine, for example, you work at a big consulting company like Deloitte or Accenture, and they have lots of people doing lots of things, and they definitely, like, if I'm a consultant, I get assigned to a new client who has a problem I haven't seen before. I want to go to the company knowledge base and see, how have we dealt with other customers who had this problem? I want that to be easy to find and current. That's just an example of what a knowledge management person might help provide. Here are the job titles associated with it, and there is someone who has a documentation-focused specialist job working for 1Password, which is, you probably know, a password management program. And there are the starting salaries. This is a job you can conceivably get without a degree. Certifications are encouraged. You know, useful information. And each of these colorful sheets also emphasizes soft skills that are needed. It isn't enough, in some cases not even necessary, to be a deep technology person. There are other skills needed in these jobs as well. Oh, a bonus feature, stepping away from the roles. Another thing that you can get out of the framework that I find really useful are these things called on-ramps. When you're in that view where there are all those tabs, and I was clicking around, on certain of those tabs you can see this on-ramps button. And if you click it, you get a display like this. And knowledge management is the role we're looking at. The other circles are also work roles. They're work roles that you commonly step into knowledge management from. So if I don't see knowledge management entry-level positions out there and I'm determined I want to go that way, I might look for a data analysis role instead and use that as a step towards knowledge management. That's what on-ramps are. It took me a while to figure that out. Technical support can also be an on-ramp to knowledge management. All right, back to our list of roles. Threat analysis is a role. And those are some of the, and again, just some of the task, skills, and knowledge for that. I just pulled out some representative ones. There are many more in the framework. This is a job to consider if you like understanding the way hackers think, attackers think, and enjoy researching emerging threats, and you like anticipating the moves of your cyber adversaries. That's this kind of work. People in this role are responsible for collecting, processing, analyzing, and disseminating cybersecurity threat assessments. And here's someone who does that for Microsoft. There's a starting salary that is a little more technical than some, so I'm not surprised to see the starting salary a little higher. More technical than some of the other roles I've featured in this so far. Yeah. All right. Cybercrime investigation, and we've had some talks today that bear on this. There are the tasks, skills, and knowledge for, you have to do things like navigating the dark web, processing digital evidence. You might like this if you have a knack for tracking down digital evidence, you enjoy solving crimes, and you want to bring people to justice, like bike thieves, for example. You are responsible in this role for investigating intrusion incidents and crimes. You use a full range of investigative tools and processes, and you balance the benefits of prosecution against the benefits of intelligence gathering. That's a kind of judgment call you have to make. And here's somebody who does this. He is a cybercrime specialist, also a probation officer, somewhere on the East Coast. I forget where he was, but anyway, concrete job people can really get. Cybercrime, oh yeah, more details about that. Notice this one has no degree requirement, although certifications are encouraged. Again, you don't have to go to college to find your way into cybersecurity. I've shown 2 examples, and there are others in the framework. I'm only sampling. Another bonus feature from the framework. Another thing you can see, you will see as you're browsing through that UI I showed, the Career Pathways UI, and clicking those tabs, sometimes you'll encounter this button, and it jumps you into another website called USA Jobs that will show you job listings keyed to that work role. So they are starting to use this work role in the industry, this framework, and its coding. And the more you find that, the more you'll find the framework will help you understand what people are asking you for. But it also is a direct job lead, and you can see, you know, what organization it's at, what the salary would be, what they're requiring in an actual job specific opening. All right, I think this was my last role to cover. Multidisciplined language analysis is the role, and it starts, you know, with knowledge of language and dialects. And that, of course, has intelligence uses. You might like this role if you're skilled in more languages than English, and you enjoy interpreting foreign communications and cultures, and you want to help uncover cyber threats from global sources. That's what this work is about. And this guy has his particular language area of expertise is Korean. He's been working for the military for a while. This kind of role combines language and cultural expertise with knowledge of targets, threats, and technology. And there's the little scratch sheet with some basic outline about that role. All right, hacker found its way in. Yeah, there is a role for hackers too. We acknowledge that. That is one of the 58 work roles. They call it exploitation analysis. It goes under those job titles. Vigilante hacker by night is Elliot's own particular job title. All right, I have a couple of slides to finish up. Just to review, I've introduced you to the NICE framework, and I've talked about 6 different cybersecurity roles that require different starting qualifications than you might have expected. I'm trying to extend our imagination of ways you could engage with this field. There is one other tool I want to introduce you to. It's called cyberseek.org, and it takes the data from the NICE framework, that is, its little database of jobs and roles, and it ties that in with actual job statistics from around the country by region. And from that site, I was able to see, for example, that in our region, in the Portland metro area, there has quite recently been an uptick in hiring in the cybersecurity workforce. That's interesting. You can get that kind of information for many different areas around the country. The same site will also let you see the data broken down by work roles, by those categories that we began with. And you can click into each category and see which work roles there are the most of. This will help you understand supply and demand around those work roles in different regional areas, which could be useful in your job hunt. Finally, I'm going to close with, well, nearly close, one more slide, I think, with this remark from the NICCS website. That's the people who put out the NICE framework. Kind of the general message from them and me for this talk is we need people in government, in the military, in intelligence. We need people with cybersecurity skills at all levels of every organization in all industries, from finance and healthcare to entertainment. There's a wide range of roles. Even the same role in different companies can give you very different kinds of satisfaction. There are the 3 main, oh, there's a third one I was going to mention. At the TAO summit earlier this month, I discovered there's a new, well, new to me, or I think it's new in town, new organization called Northwest Cyber, NW Cyber. Their website was not up yesterday, but it's coming up any minute, I'm told. And their focus is helping people in our area get connected to resources and key opportunities in cybersecurity. And they know a lot about this framework. They were excited to discover I already knew about it and was going to give a talk based on it. Kalika, are you here? I met someone at the conference. Okay, it's not. I thought we might actually have a representative. Anyway, keep your eye out on that. They do have a Facebook page that's running now, so you can connect with them if you want to. That's it. I'm done, but I would be happy to take questions. I think we have a little time. I'm certainly going to be around today and tomorrow. I would be happy to have further conversations with anyone if it would be useful. Thank you. Yes?
Do you have any suggestions for the job kind of things for people who are retiring and want to do a part-time thing?
Do I have ideas for job things for people who are retiring and want to do part-time stuff? I don't have specific leads. What occurs to me, it probably already occurred to you too, nonprofits need a lot of help. They typically don't have IT experienced people. And so if you go to your favorite nonprofit and say, I'd be happy to help, that might work. I don't know, there's a thought. Yes, a question in the back. Sorry, what was it?
What is the process for getting errors in the NICE framework corrected? A number of the roles that you identified as needing the person to actually show the fact that that data is out of date compared to new changes.
So the question is, how do we get errors in that framework fixed, that not all the data they have is accurate now? I don't know that. I assume that you would go through the NICCS website and there would be a way to report that. I do know they went through, I don't know what process they followed to get this. They didn't make them up. I don't know where it came from. And I also don't know, and they've revised it once. It came out in 2017, and they've shifted the role definition since then. There is definitely an ongoing effort to keep it accurate, so I'm sure someone is interested in that feedback. And yes, I wouldn't take any of that as gospel or written in stone. Just because that said usually a degree is required, that doesn't mean you might not get the job without, or the other way around. It's averages. So I think to
Am I like fully live? Hello? Can you do the whistle? Thank you. I don't have a voice.
This is the last one of the day, isn't it?
Yeah.
So this is the last talk of the day, except for the closing, which we're going to do in the other room, and then there's a thing after. But this is the first talk I've made to today, so I'm really excited for this. So Dr. Gecko is going to tell us about harvesting shells and farming shells and harvesting retals, not farming, harvesting, right?
Yeah.
Cool. Enjoy.
Thank you. So basic premise of the talk is just how I turned a farming simulator video game into a incident responder's worst nightmare. Having your entire company popped through a video game. Just quick overview on who I am. Currently freshman, first year at Oregon State University, working on getting my degree in cybersecurity. Yay, security club. Woo. Packet hacking village volunteer this year, and avid volunteer other villages where I can. Quick show of hands, who knows what Stardew is? Great. Perfect. So how many of you have downloaded the modding API and used a mod? Great. Have fun. Just as an overview, Stardew Valley is a 8-bit style farming simulator. You go through, progressing through years, getting different plants, and just growing crops. Also happens to have a very avid modding community, which is where I get to have fun. Why? Ego, stupid ideas, curiosity, delusions, a lot of that. And shitposting potential. Really great opportunity to shitpost. Why? C#, lots of Red Bull, fairy dust, and more delusions. How does the modding API work? Well, apparently it can respond you can have it trigger on certain points when like different things run, like an update tick, you move your character, whatever. So I decided, all right, fascinating, dig a little bit deeper. How do I turn this into an info stealer? Clearly I have access to all of this. How do I turn it into something malicious? Well, first, it's C#. Let me just test if I can make a folder. And then it worked. So I was like, great, let's keep going. Can I take data? Well, if you have Steam, if you have Stardew, you have Steam, unless you're using a cracked version, in which case your machine is already riddled with malware. So clearly, my addition won't matter. Then, your browser history is mine, and passwords, and cookies. Everything is just mine. C#, I can just use built-in Windows functions to find folders and just copy the file over. And then at this point, I was surprised no alarms had been set off through Defender. Really quiet, so I decided I would get really loud. I'm pulling the username, the MAC address, the IP address, basic system information that should make a lot of noise. Kept working, no issues. So, fine, HTTPS request at this point, like just something. Just exfiltrated data through a basic HTTPS request. Still nothing. C2. Most logical next movement path is just turning it into a C2. So back to that first point, the mods can be triggered once per update tick. How long is an update tick? 7 seconds. So it's not the fastest C2, but it still works. So just make yet again another basic HTTPS request, really clear out there, making environment variables. At this point, I was just trying to make noise and get something to trigger, and I couldn't. So loudest, like just run a command possible. It's not doing anything. I am just starting a process named CMD, telling it to hide the window, and then running my command, taking the output and putting it into a string, and then exfiltrating it through an HTTPS request again. Because yet again, all of this can be run for like 10, 15 minutes and nothing is getting triggered through Defender. Oh, and it's just run through that very top line, helper events game loop on game launch. That's the one line that hooks all of this to function. Why do I think it works is because it's under a trusted process. So Defender just opens the door wide open. It's running under Stardew, which is signed and trusted, so it doesn't care what DLLs, what anything else is being started from that process. It just knows that it's trusted and goes, awesome, welcome in. So, wrong way. Demo. Absolutely not. I said I'm delusional. I'm not that delusional. This should be the sped up version. It might not be. It's been a long few hours.
Oh, wait, 7 seconds.
Oh man. I'll put the button down. Yeah. Sorry, I thought it was really cool. It's on me. I can now focus on what the console is doing. So you can just see that it just, in the few seconds that it took for the game to fully start up, I collected all of that information and threw it back to my server with no noticeable difference in update. And now you can watch me run in circles like a maniac. But it just runs. And it shouldn't. You shouldn't let this run. I should not be able to start my own processes through a video game. I don't know why it worked. So, why does all of this matter? Well, there's a lot of open source Stardew mods. I can just take that, take my malicious stuff, throw it in there, package it, and make it some proprietary special mod and just take all of your information. Terraria also has an open source C# modding community. Pretty sure it has the same issue. Minecraft. I mean, most of us probably heard what happened in Minecraft last year where they had that worm that went through it and just infected other mods. Now you can have that and a C2. So enjoy. Yay! Questions? No, that was, so when I first tested it, if I go back. It might make a small noticeable difference, but the noticeable difference I had was I forgot the async part the first time, so it halted the game until it was finished making the request, which made me realize need to fix that. Oh. Go for it.
So there, I've had this happen before, where we had a commercial product, and we do wipe our signed lists over to client, because it's their version of the product, this mod, essentially. And what we noticed is that on Windows, if you deploy even the zip file, it'll mark the metadata on NTFS that this was downloaded from web. So it knows that this is a DLL from the internet, and won't let you sideload it to a running process in runtime. Since you're probably running it locally and didn't download it from the web, it just lets you do it.
Yeah, I assume that is probably why
There's some protection.
Okay.
Not a whole lot.
Hey, it still worked. Like, now I just depend on user error, which is prevalent. I didn't have time to add the screenshot, but there was one recorded issue where a Stardew-related thing got triggered by Defender, and all of the forum comments were just, exclude it, it's fine. So there's enough complacency for me to work. I didn't have time to work on Terraria, but it's just, I mean, I don't remember the company, but a company recently got popped because an employee used a cracked version of Beam or a Beam mod so a driving game. So there's enough people doing this and not checking because they just assume every mod is fine that it just opens up a whole new realm of intrusion.
I'm curious if you think there's any difference between like a third-party API like Snappy versus a first-party thing like Factorio.
I don't have experience in that, so I would not know. Honestly, it started as a shitpost that went way too far and took way too much effort. Like, genuinely, this started as, great, I'm gonna, like, take my friend's browser history and just fuck with them, too. I'm doing a presentation the week I had midterms.
Presumably, any game with a modding system that's based on, like, the proper version, it's gonna be affected, you presume, right?
Yes.
The only exception is that you have some kind of, like, a homegrown script library that has it right there.
Which there's a few I believe do, but it also falls on there should be better sandboxing. A DLL running under a game should not be able to just take browser information. There's no reason I should be able to, or be calling home. Like, I shouldn't need to be making web requests for a farming game. Works great for me, but shouldn't. I did not, because I do not believe this is inherently a vulnerability. It is just an unintended feature, because I don't know if this falls under Stardew or the modding API to sandbox, but either way, if it's just C#, like, maybe have something that is a little bit, I don't know if it's higher or lower level, but takes more, like, interpretation can be better suited to not have this happen. Okay. Next time I have a life. I'm a first year. I have a midterm on Monday. Yay. Any other questions? Yay. Can I go home now?